Good morning, everybody. Thank you for accepting our invitation and joining our meeting. We have quite busy program today. It's an event of Europe Union Industry Week, but it's lasts from February to April. It's COVID, nothing to do. It's very fast, and it's more dedicated to two big European projects. It's PhotonHUB and PULSATE. And with a lot of opportunities to companies to use European support and to get some support also from partners with in adopting photonics and laser technologies. So you will hear some information about how to apply in open calls. And then the program is split into four parts. So one initial part, it will be some plenary about welcome from our ministry and so some information about progress, and we will show Lithuanian and Polish somehow ecosystems, what we have in this area. I will pressing my colleagues to work more on vision where to expand our laser and photonic community. So we have a special session on that. After lunch, we will have more information about how to apply for open calls for those projects. Some of you selected to pitch your ideas and to look for the partners for those projects. We will hear some best examples from previous projects, and we have some time for matchmaking and discussion with partners. So be not shy. This is online where you can listen and make some question and comments on chat. And also we have networking areas that will open during the lunch break and after finishing the sessions, where you can really in very relaxed time to discuss more how we can proceed. And now I pass to the first moderator, Francesca from EPIC, to start the first session.
Thank you very much, Gediminas. So welcome also from my side. My name is Francesca Moglia. I'm from EPIC, European Photonics Industry Consortium. We are involved in both these fantastic initiatives, PULSATE and PhotonHUB. So we are really glad to be here and to announce a bit, make the first really meeting together. And I'm also really pleased to be here and moderate this first session. As Gediminas said, it will be a bit the introduction to the two initiatives, but also the introduction and greetings from the two countries that are involved today, so Lithuania and Poland. So it's a great pleasure for me to introduce the Vice Minister of the Lithuanian Ministry of the Economy and Innovation, Eglė Markevičiūtė. So please, Eglė, the floor is yours.
Dear participants, first of all, Francesca, thank you for pronouncing my last name so perfectly. This is not an easy task for non-Lithuanian speakers, so thank you for that. Dear participants, it is my great honor to welcome you to this conference, one of the numerous events organized all over Europe as part of EU Industry Week 2021. Photonics are definitely an essential to our ability to fundamentally address the enormous global societal and environmental challenges that we're facing today. Photonics are also critical to the functioning of new applications, which are powering the new industrial wave, Industry 4.0. Lithuania, as well as other European regions, gets massive benefits from Industry 4.0. Implementation of its principles ensures a significant increase in safety, quality, and reduced waste. It is definitely not just about generating increased productivity, but also about long-term high-value careers, because jobs change as we are introducing Industry 4.0 technologies into economy. Over the recent years, there has been a lot of things that have been done to stimulate the digitalization of economy. by injecting companies with technological know-how and financial support. We have also encouraged companies to increase their cooperation, sharing, and networking. A good example of tools for achieving these goals would be the digital innovation hubs. Just to mention a few digital innovation hubs cases, success stories in Lithuania, Ministry of Economy and Innovation has finalized results for the call on the measure, and approximately 17.6 million euros have been allocated for digital innovation hubs for the development of infrastructure and provision of consultations, mainly to small and medium companies. I'm sure that photonics industry will be among others that will greatly benefit from these digitalization initiatives. Certainly, laser-based technology can radically change many industries and provide maximal benefits towards flexible manufacturing and highly digitalized production environments. Without a doubt, European industry needs to be at the forefront in innovating with photonics, making the most of our combined strengths across all parts of the innovation value chain. And we definitely have to work collaboratively across all member states in order to support European business innovation and growth. Lithuania has made a considerable breakthrough in the area of photonics and will certainly continue this way. However, it is important to increase exports by integrating into international laser applications value chains, increase sales in the internal market by offering digitalization solutions for local companies, attract foreign investments by attracting strategic investors to the sector. Very special attention should be paid to small, medium enterprises because they are the motor of European innovation economy. Lastly, well, it is probably evident that even small countries like Lithuania can build their future successfully, in particular, walking hand in hand with partners from other regions. I certainly do hope that today's conference will allow to make an additional step in that direction and contribute to the increased international cooperation. So I wish you all a very productive day with meaningful discussions. And on behalf of the Ministry of Economy and Innovations and the Minister Aušrinė Armonaitė, I thereby state that this conference is open.
Thank you very much. And also thank you very much, Gediminas, for training me so well in pronouncing her name correctly. So thanks a lot. I have to say that it's true, Lithuania is a small country, but in photonics is really a big one already, in laser technology, but also in photonics in general, and we will hear it also later on. So that's, of course, a great start. And now I guess it's the time for us to also listen a bit to the two initiatives that actually are here together, funded by the European Commission and like support Lithuania, Poland, but also the European photonics industry and SMEs and also large one. So I would say let's go on and let's go to Hugo Tiempont, that is today representing the coordinator of PhotonHUB in PhotonHUB Europe. And today we'll talk about PhotonHUB, Photonics Innovation Support for European companies. So Hugo, the floor is yours.
Thank you so much, Francesca. I hope you can all hear me well. So, welcome to PhotonHUB, the Photonics Innovation Support for European companies. My name is Hugo Tiempont. I'm coordinating this initiative, and I'm really happy with the speech of the minister because she introduced really that SMEs are Europe's innovation economy strong support. It's really the lifeblood of our economy. And I must say that the SME sector in Europe represents more than 24 million small, medium-sized enterprises. And what I think is really important is that they make up more than 99% of all the region's businesses. They account for 2/3 of all the employment in Europe, and 260,000 of them are actually innovative enterprises. Those SMEs are active in a variety of industry sectors, from health, manufacturing, agro, food, safety, security, energy, mobility, and digital infrastructure. And all these industry sectors need innovation and digital transformation. And there are 8 key enabling technologies that are driving the processes of discovery, innovation, and digitization. And you see all of them here, and photonics is one of them. Photonics, the science and technology that innovates with the unique properties of light. I think you know a lot of those applications of photonics: the optical fiber data communication, the solar cells, the durable LED lighting, the displays, the machine vision, medical optics, lasers in manufacturing. All of those are really key, and they provide Europe with a very strong position in photonics on a global scale. Europe has 16% of the photonics world market share, and that represents more than 100 billion euros. So it's gigantic, and it's really, really important. Moreover, it seems that the compound annual growth rate for photonics production in Europe is 7%, which is way above all the other production rates. So the growth is phenomenal, and it provides Europe with a very strong export position. Photonics impacts at least 10% of the European economy, and there are 5,000 small, medium-sized enterprises in Europe that work in photonics, giving direct jobs to 380,000 people. So the economy of photonics for Europe is really, really important, and there are several photonic segments where Europe is very strong in. The production technology supported by lasers, machine vision, optical component production, photonics in the medical technology, defense, lighting, and communication, those are the strongholds of the European photonics economy. And as I said, there are 5,000 photonics SMEs working in photonics, but there are also 260,000 high potential SMEs that can benefit from photonics innovation. And we are really going to target both. That means photonics companies, but also the non-photonics companies. But if you want to really see those SMEs thrive, if you want to see them do good business with photonics innovation, those SMEs need support along the entire innovation valley of death, from the basic ideas, turning those ideas into prototypes, upscaling the prototypes for manufacturing, doing the manufacturing, and finally also launching the product on the market. And that's why we started this PhotonHUB initiative as a pan-European one-stop shop for photonics innovation, where we're going to really help the SMEs. We take them by the hand, we're going to orienteer them, we're going to help them with training and reskilling of their people. That's absolutely necessary. We provide deep innovation support through projects. I'm going to say a few words about that later on, from TRLs 3 to 8. And then very essential for the SMEs, business coaching, investment coaching, and also linking them up with regional funding. So PhotonHUB at this stage brings together 36 technology support partners from all over Europe, 6 business support partners, and 20 local photonic hubs. More than 500 experts are ready to support those SMEs from 15 member states. And you see here those regions that are strong in supporting photonics: Lithuania, Poland, lighthouse regions, also early adopter regions, and of course a few others. And there are others that I think we still need to support, where we would like to create new hubs. Talking about those hubs, of course, if we want to support SMEs, we have to reach out to them and tell them who we are. And that's what we're doing also today. So PhotonHUB is going to create outreach campaigns to SMEs, but we're also expecting all those local hubs to bring on those SMEs that are in need of photonics innovation support. And we're going to then bring those SMEs through our innovation support pipeline. Now, suppose that that a company needs innovation support, photonics innovation support, and that best support can be found locally, then we're of course expecting that both the company and the RTO are going to use the regional funding to support that. But if the best support for photonics innovation is found in another member state, that means cross-border, then PhotonHUB is going to fund that support from its financial resources. And the financial resources of PhotonHUB are 19 million euros. So we're going to really be able to help a lot of SMEs. We're going to ask them to register their interest. We're going to orienteer them depending on what they need, training, business and financial coaching, and especially deep technology support from TRLs 3 to 8. And so what we're going to do, we're going to send technology scouts to the companies to discuss the challenge, because we listen to the company and we listen to what the company needs, what their real innovation challenge with photonics is. And then we're going to help them through innovation projects that in most of the cases, we're going to financially support with EU funding. And we're working at 3 levels, TRL 3 and 4, where we're going to accelerate the prototyping through innovation projects. TRLs 5 and 6, where we're going to help companies that need support in upscaling of their components, and we're going to link them with the EU pilot line facilities. And finally, also, when companies are looking for manufacturers of optical components and systems in Europe, we're going to help them through brokerage support. What is important is to understand that indeed we work at those 3 levels with the companies for innovation support. However, the lower the TRL level, the higher the financial support from PhotonHUB. You can see that here. We are expecting some cash, but that's not a lot. Okay, the cash contribution from the companies is really limited in order to decrease the roadblocks to innovation as much as possible. We have 8 technology platforms ready to support the companies: free space optics, polymer optics, specialty fibers, micro electromechanical systems, 3 platforms on photonic integrated circuits, silicon, silicon nitride, and indium phosphide, and the laser-based manufacturing. All of this for helping the companies with prototyping. When it comes to upscaling, we help them by linking them with the pilot lines in photonics. You see them here. I don't have time to go into the details, but there are several pilot lines that really help the upscaling of the components. And if they are not, if the technology is not found in those pilot lines, we will surely be able to link them with other pilot lines that do exist in Europe, but that are not funded by the European Commission, and help them out with our funding. Really important also is trying to provide the companies with skills and training, because very often they miss expertise and skills in photonics. So for first users and early adopters, we're going to make sure that those SMEs get general introductions to photonics so that they understand the advantages. We're going to have an online catalog of existing training offerings. We're going to set up demo centers and experience centers, where the demo centers can be visited by the SMEs to see what the applications, what applications photonics has in store, and experience centers, which is something completely different, where the companies can come for hands-on experience. And finally, also important, we're going to have a kind of cascade training by training the trainers program, especially with vocational training centers. If you want to grow, or if you want to start up a company in photonics, you need investment. So we have an investment readiness program where we're going to intensively support and coach the companies with investor pitching and matchmaking support, especially for high potential startups and scale-ups. And we're going to organize for those companies venture forums, one dedicated to photonics, which is the European Photonics Venture Forum, one dedicated to those companies that would like to use and benefit from photonics to upgrade their products. But those companies are not really photonics companies. And for those, we are setting up LITEK Innovation Days. Finally, I think it's really important to work together with regions. We're going to work together with the regions and the local politicians to find financial mechanisms really to support those SMEs that need either local support or cross-border photonics innovation support. So this is more or less our political mission, a really important one. You have seen we have 20 local hubs in photonics already, but that's not enough. There are certain regions in Europe that do not have a photonics innovation hub at this stage. We're going to create new local hubs or work together with the digital, existing digital innovation hubs and link up with them also for photonics. We're going to connect also our PhotonHUB network with complementary digital innovation hubs in Europe. One's on manufacturing industry or robotics or artificial intelligence, because photonics alone can do a lot, but can't do everything. So we really have to get in touch with those digital innovation hubs. And finally, PhotonHUB will not stop when the funding of the Commission stops. PhotonHUB will continue as PhotonHUB Association 2024. So we're going to execute and roll out a business plan so that we really can continue working with all the SMEs later on. Now, it's all about having impact on our economy and on our society. And that impact is something we really are going to measure. So we have key performance indicators that I'd like to share with you to conclude my presentation. We're going to try to raise awareness of the photonics innovation potential with about 100,000 SMEs. It's really important that they grasp the innovation potential of photonics. And most of those companies that are going to benefit from our support will be SMEs. We expect 90% of the companies to be SMEs. We expect 5,800 companies to visit our demo and experience centers. We'll launch together with the companies 170 new photonics enhanced products directly linked to our innovation support. It's of course really important to increase the company's revenues directly linked to what we're doing. And we expect 750 million euros there and 100 million euros new business for the existing EU photonics manufacturers. And finally, we think we're going to raise a lot of new venture capital for those startups that will work with us and that we help through the investor matchmaking supports. And in total, that will be around 150 million euros. And of course, essential, 1,000 new high-tech EU jobs within this and 4 years. As such, we are really looking forward to, together with all of you, win Europe's future and keep Europe as a real stronghold in photonics innovation. So I invite you all to connect through either sending us, if you're interested, an email to info@photonhub.eu or visit our website. And this afternoon at 1 o'clock, my colleague Nathalie de Baas will give a presentation on how to apply for our services, and I'll be available at 10 to 4 for the matchmaking event. Thank you.
Thanks a lot, Hugo. Thanks a lot for your great presentation. So I see there are no questions because I guess they are all impressed. When they hear the first time about PhotonHUB, people are like, so that's probably the reason. But I can ask a real question. So what is really fascinating that this PhotonHUB is doing is really also this connection among different countries. So I guess this is the value also that SMEs from different countries that really maybe usually are not every day in connections with the foreigner companies can in this initiative really connect to each other. Can you comment on this value that PhotonHUB is giving?
Yeah, I think it's really important to be able to reach to all the SMEs that need photonics, okay, and photonics innovation. So they can either join us by going to their local hub or by directly coming to us. If they directly come to us, we'll immediately have a person that will take them by the hand and that will go from A to Z through everything they need. That's the goal of the one-stop shop. The fact that we're trying to find the best support in Europe, I think is really great value, because very often these SMEs are looking for support in their local neighborhood. And they may find or they may not find information and the necessary support, but they're never sure whether that is the absolute best support that Europe has to offer. And that is the difference we'd like to really make. We just want to make sure that when the SMEs innovate with photonics, it is with the best photonics that Europe has available, okay? And not with second best, so that they don't lose funding, they don't lose time. And that is why PhotonHUB is the follow-up of Act Fast. We want to continue with acting fast with those SMEs.
Yes, that's a good principle. So let's keep the momentum and go on also with activities that were already successful before, and so now can really take a further acceleration with the PhotonHUB. So another thing, so let's not maybe talk now about how to apply, because also Natalie will speak about it later. So it's also an opportunity for all the SMEs listening also to listen a bit more and ask her about how to get in contact with you. But another important question that came to my mind is, you mentioned the collaborations with the other initiatives. So, for example, the digital innovation hubs, but also our other pilot lines in Europe. Can you also specify there, maybe comment a bit more, what is the value there and how really PhotonHUB will interact directly with these initiatives? Because, you know, EPIC is involved with some of them, and so especially with the pilot lines. So it's interesting for us to get to know how we will interact to each other.
Okay, first of all, Francesca, EPIC is doing a great job in promoting those pilot lines. But of course, as you know, all those pilot lines, they have a 3 to 4 years lifespan. Okay, and they should continue after that. And because the Commission is not going to add additional funding, they have to be self-sustainable, which is very difficult. So what we have thought was, why don't we link up with all the existing pilot lines, and why don't we use the funding that we have in PhotonHUB to continue the services that they are offering, lowering the barriers for all those SMEs? Because if an SME otherwise would go to the pilot line, they would have to put a lot of cash on the table if the EU funding stopped. Okay, and that's going to happen in the year to come. Okay, many of those pilot lines the EU funding is going to stop. And fortunately, there is PhotonHUB, and fortunately, we all team up under one umbrella. If an SME needs support from these pilot lines, they can come to us, and there is up to 250,000 euros of funding that they can really use. Of course, they will have to match themselves with a certain percentage, but the good news is that a big chunk of the costs will be supported by PhotonHUB. And as such, we're going to be able to stretch the lifetime of the pilot lines for several more years. And hopefully by then, they will have so much business that they will be really self-sustainable. So I think it's really good that SMEs can both have support for the prototyping, TRL 3 and 4, but also a seamless continuation to the TRLs 5 and 6, and if needed, to 7 and 8. And that's what we're offering. And that is really, I think, the unique proposition that we have.
Thanks a lot. Thanks a lot, Hugo, also for this further details. So I would say now we give the word to the next speaker, so that we can then afterwards make a bit of a discussion together between PhotonHUB and PULSATE, so that we heard then from both of them. So now it's a great pleasure for me to give the floor to Pablo Romero, that today is representing the coordinator of PULSATE, and he will, as I just announced, describe a bit how PULSATE works. And so the title of his talk is PULSATE Activities and Opportunities for SMEs. So I guess it's time to give the floor to Pablo.
Well, thank you very much, Francesca. And first of all, thanks to EPIC, FTMC, and LITEK for organizing this day, and all the scientific, industrial, and community in Lithuania and Poland, and the authorities from both countries for involving in this event, and for inviting both of our projects. And it's a great pleasure, of course, to present. Let me share. Yes, I think you can see my presentation, right? Perfect. So good morning, everyone. And I forgot to thank also all the attendees connected, who are quite a nice number for this time in the morning. So thanks everyone. And well, in this first slide, you just see the name of the project, but you see a couple of important information. First, it's a photonics project because we are dealing with laser technology, but it's also an I4MS project. I4MS is an initiative from Europe to impulse innovation in manufacturing SMEs. So the main idea is to return manufacturing to Europe. It's a big thing that we have from the first industrial revolution. It started in Europe, and Europe has a long tradition of manufacturing and of advanced technology in manufacturing that has been abandoned lately towards other areas in manufacturing, and we have a huge potential of recovering jobs, business, and quality living by returning high-level manufacturing to Europe. And laser has a big potential in terms of impulsing high quality and high-end manufacturing in Europe. Laser is the eternal promise of a perfect manufacturing with no degradation or very little degradation with time. It has no moving or wearing parts, and it has consistent parameters and quality throughout the time, and it can provide unprecedented energy density exactly where you need it. So laser has a great potential to be an enabler for transforming manufacturing in Europe. The problem is here with SMEs. Laser is very well established in large companies in like automotive industry, pharmacy, and so on, big companies, and it has some difficulties to enter manufacturing SMEs. And we have detected barriers from the manufacturers of equipment. The biggest innovators in manufacturing of equipment for laser are also SMEs, and they trying to incorporate products in the industry. We see a number of barriers, and from companies trying to adopt laser technology back to their manufacturing, we also see a number of barriers. The barriers that we have identified in 4 main areas. Technology, which is, well, directly the technology itself is difficult to access, to manage, and expensive. But also the link to all the infrastructure, digitalization, and so on of the integration of the technology. It's not just the lasers, it's all the machinery around. Its competence using lasers requires a completely different set of skills than using other types of machine tools. The way it removes material, it adds materials, transforms materials is completely different than one from mechanical means. So you need a different set of knowledge, and standards are not there at the same level as other types of equipment, and training is not as really, so there's lacks in here also. Awareness is something very important. Many companies don't use laser because they don't know that lasers is useful for them, and it's something that we also have to help companies to access the success examples and good practices, and also general awareness of what laser can do for them, and all related with business, which was mentioned perfectly by all the previous 2 previous speakers. access to investment, the huge risk of radically changing your technology and using laser instead of other types of machine tools or welding technology or micromachining technology. Using lasers makes a deep impact in the not only the production itself, but also the type of product you are able to do, the business model you can access, the process and product flow and data flow. So that makes a big impact in business in general. And there's financial needs and need to know about your market. So PULSATE as a project is trying to get information and get what we call adoption models, models that harmonize all those areas and help SMEs to access the technology in a more smooth way and access the digital single market, the next wave of digitally transformed business and opportunities by adopting laser technology with less stress and less risk. And we plan to support mainly 6 markets, 6 types of industry. Of course, we are open for all types of industry, but we have seen that this has the largest potential to improve by implementing laser technologies and have large success stories in big companies, but huge still unused potential in smaller companies, mainly aerospace, medical devices, electronics, automotive, industrial machinery, and textile. And we have as the main tool, the main instrument for the companies to access the technology, what we call the experiments, the 2 types of experiments: large experiments, which are technology transfer, where they are mainly enabling access for companies to infrastructures and to test facilities. So the companies can access up to 150k euros direct funding for them, just to set up a test environment for laser technology to their particular needs. So we open calls for experiments. All companies in Europe can, SMEs companies in Europe can apply and provide their ideas on how they want to experiment different technologies that potentially can help them to manufacture better, to manufacture more quality products or new products or high digital data chain or any improvement they want to do through laser-based manufacturing. And we provide them with that direct financial support for making their own experimentation together with providers of innovative laser technology. And on top of that, we support them with all the 4 areas of support, with our own infrastructure from the top laser centers in Europe, our own knowledge by training them, by providing them with existing knowledge packages, by supporting them also to find further financial resources, and by also helping them to raise awareness on what can be done later on with the laser technologies, and also to access new markets. And adoption use cases, which are shorter experiments, just 3 months, for techno-economical evaluation and assessment that can be provided after technology transfer experiments. So we think we have a quite good model for providing a large number of SMEs. We want to provide up to 200 SMEs with that kind of services and support during our 4 years project. But beyond that, we want to use that to build an infrastructure to support further industries in the future by creating a marketplace of services for laser-based manufacturing, both software-based and infrastructure-based, by providing a large number of training activities. We want to reach a large number of trainees after the end of the project, and by incorporating to our network a larger and larger number of companies that need this support to access the advanced laser manufacturing, including additive manufacturing, but not only limited to additive. And we expect in few years after the end of the project to create this type of network based on our financial infrastructure and knowledge support to companies, this kind of network that will survive up to the end of the project and can engage companies at different levels. Just customers that come for a single test for us, and we just sign a short agreement with them and give a simple service to them, or a sustained and long-term relation with member partners that can last for years and can allow larger impact in the industry in Europe to flourish, thanks to innovation ecosystem that will be activated through not only financial sources, but mainly these adoption models that we're talking about. For that, my name is Pablo Romero. By the way, I'm working in one of the competence centers in Europe, in Spain, called IMAN. But together with us, with IMAN, we have the strongest centers in Europe, including SINTEF in Nordic area, CA in France, Fraunhofer in Germany, the Center for Physical Science and Technology in Lithuania, our host today, MTC in England, and supported by the strong support of Funding Box and EPIC in the business intelligence and networking, and Glasgow and SME expert in digitization. So we are here to support adoption of laser technology in manufacturing. This was our vision, and I hope it will be helpful for the SMEs in your region and area. Thanks a lot, and I'm open for questions.
Thanks a lot, Pablo. Thanks a lot for the nice introduction to PULSATE, and also for now the possibility to get an overview of both the initiatives that we have here in the room. So it's nice to use the questions that we have now from Gediminas to maybe both of our speakers so far, so both Hugo and Pablo. So the question is, most of such European initiatives were for lasers and laser industry or for photonics to photonics industry. So how to encourage actually companies having no experience with the technology, because that's the core, to actually engage with these initiatives. So please, can Pablo start maybe, and then Hugo maybe can comment as well?
Yes, you are right. The main barrier we encounter for a number of technologies which has a huge potential in industry is that manufacturing SMEs don't really know the benefits they can have with laser technology. We have the link to I4MS community. I4MS has been active for a number of years. Now it's 8, 9 years, something like that. And it's a large community of companies which are related to manufacturing, but not with lasers necessarily, not to photonics. And they have the need for implementing digitization and advanced manufacturing. And we are using that existing infrastructure and community to incorporate the idea that laser is a key enabling technology. Laser, not only laser, industrial photonics, which is lasers, it's optical metrology, it's optical quality check and photonics-based quality check in general, and also machine vision that's mentioned earlier. So all that can help improve manufacturing, and we are mainly using that to make the message reach companies. But also digital innovation hubs and European digital innovation hubs are a way to reach a larger number of companies, mainly in regions which are not especially active in the European research arena, and which have only a regional activity. So we are in the mindset of acting at European level, but reaching the regions through digital innovation hubs.
Very good. So it's a kind of a further step after the steps we are already taking to get into this, yes, activating also SMEs a bit far off from the technology. So Hugo, what is your opinion? So what is the feeling? How will also PhotonHUB engage the non-photonics company in really get involved?
Okay, I think getting the non-photonics companies and SMEs involved is one of the most difficult tasks. Okay, it's very, very challenging. But we have some experience over the last 10 years on how to do that. We failed many times. The way we're tackling it now, and that works pretty well, is by working with outreach groups that each are targeting a certain industry sector. For example, we have an outreach group on photonics in health. We have an outreach group on photonics in food, photonics in textile, photonics in whatever. Okay, and we're going to look to the clusters that work in those industry sectors, and we're teaming up with them. We're working with them. We're giving presentations. That is one way of doing it. Okay, and just saying photonics will do a lot of fantastic new things for you is not good enough. You need star performers. So fortunately, over the last 10 years, we have been working with maybe 15, 20 different companies from 10, 20 different industry sectors. So we have a fantastic number of examples from each of those application areas. And we call them our star performers, okay? And we bring always forward those star performers, for example, on a meeting with companies that are working in the textile. We bring forward those companies with whom we have been working in textile, and we show how they have been thriving by using photonics, how they have been solving challenges, how they have been growing their businesses. And by showing companies that they know, or by showing companies that work in the same sector, that really inspires all the others. And then they come to us and then they say, this is my challenge, can you help us? And that's what we're then doing. Another way of reaching out, and then I'll stop because this is something I have been really liking for many, many years, this challenge. Another thing we do is we work through the Europe Enterprise Network, and Europe Enterprise Network is creating or is organizing fantastic brokerage events, either face-to-face, but now also digital, which means we can screen companies that are there and we see who they are, what they do. We ask a 10, 15-minute discussion with them. And during a whole day, we talk with 20, 25 of those companies. And I think certainly 20% of those are really interested in what we can offer. And we create leads from there. And that also really, really works. So There are many other magical formulas that I could share, but in view of time, I will stop here. But there is a way to do it, okay? And there is also a way not to do it.
Well, great. So that's the to-dos and not to-dos. That's the important things to know, right? Because no, great. So you're also learning, of course, for past experience, but I really would say these outreach activities are really also very important. So the scouting activities. So I have to say in PhotonHUB, there is really a massive activity foreseen to really get into new topics. And that is also a bit what EPIC is doing now. So I feel the synergies more and more. So that's very good to hear. And now I have a couple of questions more towards Pablo and PULSATE. So it's important this to understand. So let's focus on these questions because this was asked by Egidius from Ivana Technologies. PULSATE program is just for additive manufacturing supporting photonics technology or could be applied for any photonics technology development project? Let's maybe there are two things. Yes. Additive, not only. So Pablo, please.
Yes, the main restriction we have is that you need to use lasers for manufacturing. It's not limited to additive, I mentioned before, but we stress the additive in our title and in our activity, because additive manufacturing has been identified as one big transformator of industry, and is very useful also for manufacturing a varied range of products, geometries, and also batch sizes, from single batch to mass production. So that's why we stress the additive manufacturing, but we are open for all types of laser-based manufacturing. What we mean by advanced and laser-based manufacturing is that you need to bring some innovation, some improvement of your production or your product. But it's open for all types of laser-based manufacturing, yes.
Very good. And also, yes, so advanced also manufacturing is the important part. So we have also a couple of questions from the chat. So from you watching us on YouTube. So from Jonas Bulaitis, he's asking which industry you think will be the most impacted by laser solutions?
Sorry?
Which will be, in your opinion, the industry that will be much more impacted by laser technologies and laser solutions?
Oh, we expect all industries to be impacted. The lasers have strong, combined with other technologies. Lasers have a huge potential to impact all industries. For instance, we are dealing typically with all types of material machining that can be used in all industries for substituting traditional machine tools. But when you talk about, for instance, the big potential impact of micro laser technologies in surface modification, like producing self-cleaning or antibacterial surfaces, you can imagine what's the potential impact in the current situation with all the changes we need to do due to the pandemic and so on. You can also modify surfaces to change their aspect. So in luxury industry, you can make a huge impact by producing effects that you cannot produce in any other ways through nano texturing, and even other types of effects like tactile effects or surfaces with optical effects that cannot be matched with any other manufacturing technology. And that could not be done with traditional lasers, which are very small in producing nano textures, but there's coming a huge wave of innovations in laser equipment in optics, in machine architectures that will provide the ability to texture surfaces at large speeds and with reasonable cost. That's only an example. Laser surface modification and surface texturing. It's just one example that can be used from luxury and even agriculture and textile industries down to all kind of machining of metals and plastics.
Yeah, thanks a lot, Pablo, to make these examples, because as you just say, sectors of industry, people really don't get the feeling. But once you give the examples, maybe the wow effect is really contagious. So I guess this was a really nice way to attract also this kind of sectors in industry, so to give the real examples. So now we take one last question from my CTO, Jose Pozo, so I cannot not ask this question, that he will speak later also a bit about EPIC, so it's good for you to know to stay tuned. So is there room for cooperation? So that's the question, between PULSATE and photonic technology suppliers, so not clients, of novel lasers or laser optics? That means, can they offer this technology via PULSATE to make sure that the service of PULSATE are at the edge of innovation?
Mm-hmm. Yes, our ambition is that we will build this community, as I mentioned, of innovators in laser equipment, optics, and laser, not only sources, in general laser machinery for manufacturing, and we want to be an enabler to enter new markets. So it's bidirectional. One of our main tasks is to make industry aware of the ability of lasers, but the other one is to help innovators in laser equipment to provide their services to more and more industrial sectors. So that's one of the things that was mentioned also before, that we need to outreach new industrial sectors, and our ambition is to have a stable contact with the sectors that are potentially adopting technology, and also help the innovators, the companies providing technology, to make their products more friendly and attractive to manufacturing SMEs, by identifying what make the manufacturing SME select their equipment and choose their equipment better than another, and why laser could be more attractive. So for that, we need, again, to identify, as I mentioned, the entrance barriers beyond what we have now, and these adoption experiments, I hope it will be help to be key examples for successful adoptions in the future.
Yes, very good. And I have to say here, we have in the chat another keywords, e-mobility, dlin. So this will be probably a really great enabler for laser-based and advanced technology. So that's definitely a good observation. So there is a really a real span of activities that also, depending on the market behind, will be, of course, a great push. So it's also our task with PULSATE to support them all, and then see also where is the most chances to go even broader and push it. So now let's stick to the agenda. So now let's not talk too much. I mean, it's always like this, right? Once you start to talk, now you cannot stop. But let's give the word to our virtual host now. So we would have loved to be all in Vilnius today, but we cannot. But we have now a further talking from Vilnius today. So it's down now to give the word to Gediminas Račiukaitis, Head of Laser Technology Department, FTMC, LTS. And today he will introduce FTMC and LITEK as the Laser and Photonic Competence Centers. Thanks a lot, Gediminas. The floor is yours.
Thanks, Francesca. I tried to share my presentation with you. And why we are here and why this event is happens, how to say, and our supervising, it's because we are involved somehow in those projects. And if we move now to this, the local people probably knows, but we are from FTMC, Center for Physical Science and Technology. We have scientific park in our campus. We also have LITEK, so Laser Engineering Technology Cluster, all in one campus, everything in one. And we are involved in PULSATE, LITEK is involved in PhotonHUBs, and if we count all three, we are Laser Digital Innovation Hub. And it's one-stop shop, local, regional for this country. And now we go to some parts. So Center for Physical Science and Technology is the largest research institution in Lithuania, working in different fields of physics and chemistry. We just celebrated a year ago, now we're 11 years old, so close to 700 people. And in those projects, we are represented by Department of Laser Technologies. So it's 7 laboratories, and we have 86 headcount, working in different fields from optical coatings, laser developments, development laser technologies, some plasmonics, and implementations of those technologies to industry. And as a result, we started some in the European activities in Apollo project some years ago, and now we are part of another 2 continuous of this idea for other European community. So I go through some topics, what we are doing. So advanced technologies for optical coatings. So we have some technologies for all silica coatings that use only one material to make coatings on your food silica substrates. And it's really, we're getting quite fine spectral response and polarization response. And the most important, it's very high damage threshold for those coatings. It's one of the advanced stage, and it's really our laboratory is working on. Another topic is working on the structuring surfaces, on structuring substrates, or growing structuring surface itself for different application, for optical application, also for spatial filtering of the light, and also they are directly applied like sensors, like photonic devices for various sensing applications. If we go to laser development, so we have 2 activities in fiber laser and solid state. One I selected, so we developed some ultra short pulse oscillator fiber-based. We patented it as a center, and we licensed this to our spin-off companies that are now making commercialization of this product. Another is solid state laser. It's really traditions of Lithuania to be in a solid state lasers, if you look on light conversion or extra companies, and so we have a laboratory working very complex laser systems, new generation, stable top system for terawatt intensity levels. And going to some material processing activities, we have so broad areas, so only selected very few. One is material processing and fine working on the glass, so we can cut or process glass in very narrow thick pieces and do 3D miling, and it's more interesting so we combining with other laser-based technologies for glass processing. We can make very fine structures in fused silica, and they can apply also for another kind of the lasers, very intensive lasers, like gas nozzles for laser wake field acceleration. We've shown this very long-term operation of this kind of the nozzles with those kind of the lasers. We have activities on additive manufacturing, not too much experience as other partners in PULSATE, but nevertheless we're working on that. In direct metal printing, we are printing technologies for polymers and ceramics, and we're also working on new methods for laser-based 3D printing of the materials. We're working on industrial laser technologies related with the robots, try to combine laser technologies with more complex that it's installed. So it's one is our response to COVID. So transforming PET bottles to face masks. It was developed in 1 week. And also we have a lot of activities in 3D material ablation to be fast and precise for micromolds or surface functionalizations. One activity is started in Apollo project with partners from Europe and also from Lithuania. So making selective metal plating on dielectrics, initially on polymers and laser-based activities. We have patented this technology and now going to the way how to make it commercialize. So it's 3D electronics circuits on the molded polymer plates. Now we are going to another substrates like glass on transparent flexible substrate. We have now national projects. It's common, those 3 projects, 2.5 million. So it's quite big. We have some small spin-off working in this, and really we are now moving, if we start in those projects from the technology validations, transferring this technology to other substrates. Now we are more concentrated on how to applications, so energy harvesting, how to apply this technology, making sensors, networks for food safety, etc. So it's really where we are trying in our department move more far to application areas. And good that in all this area, what we are working on laser application and material processing, we have a group of companies that are working on different aspects of laser technology development, like making models for laser technologies, developing some technologies. We have company of software or system integrations. So we can build really complex laser machines based in our community, but now it's also interesting that we have a group of new companies, spin-off departments that are really more concentrated on specific areas of applications. So not developing system as itself, but really looking at the products that can be made by using those technologies. Now we're going to this next part of this our triangle. So LITEK, it's a combination nearly 20 companies, and what we are doing, so in creating value chain for the technologies for lasers and engineering companies, bringing those technologies closer to industry and to make it enhancing some cross-sectoral collaboration and knowledge exchange between those companies. It's really trying to, that's in LITEK, work on this value chains from optical component, pieces of glass, coatings, laser optics, optical systems, laser systems, and applications. And also doing some research, concept development, training, marketing, consultations, coachings. And last part, but it's quite important part, is science and technology park we have in our campus. It's really for growing startups in laser and photonics and optics. So advice in business development, incubation of spin-offs, access to researchers, experts, and matchmaking, rapid prototyping services as helps to companies in our campus and more broader to make easier this development. And all together, we are laser and LT digital innovation hubs. Really, we are doing test before invest and consultation, training, doing innovation and digitalization audits, trying to transfer knowledge, facilitate to get access to the finance with different activities, including face-to-face meeting, testing laboratories, and visit to our labs. Of course, we are part of Lithuanian laser and photonic ecosystems, with a lot of companies, 40 companies, thousands of people working in this field. And now we have vision, it's our campus with 3 hectares. Now we have vision to expand our campus 5 times. And now we are really in second sessions, is some ideas, what we could put in this old garages and something in this forest. It's really, I would like to provoke you, so some bright ideas what to do on that. And thank you.
Thanks a lot, Gediminas. Yeah, that was my provocation, actually. I wanted to hear more about this future because I saw this slide already and we never had the opportunity to discuss this. So what is really the plan? Because you are already more on laser focus, of course, you as your institution, but of course also the Photonics, so LITEK will want for sure to have a part on it. Can you make already some speculation? What are your dreams, at least, for this new area?
Working, okay. Initially, it's make laser for material processing on science. Now we have some laboratories working on photonics and plasmonics, so this is sensing. Now we are discussing quite a lot of the quantum communication and etc. So it's another opportunities, and it's really we not should press our community first, and we really this meeting is like initial step for us to start more intensive collaboration and discussion internally in our country where to move and to have some roadmap with how we can expand our activities in different fields.
Yeah, I can say that EPIC is already starting as well with quantum technology. So EPIC has already a vote for this for sure. But it's definitely true. You should ask the community. So the community is also here today to also maybe make some suggestions. So please don't forget about this provocative but actually real question of Gediminas. He wants to know what to build there in the upcoming years. So please also write it in the comments. We will communicate everything you tell us to Gediminas so that they can make a real plan. Okay. So now we have to go to the other partners. So Poland is also a part of this event today. That we, of course, it's fair, let's say, because we are not actually in Lithuania physically, so we couldn't have been in both places. But with this virtual world, we can actually be in both places simultaneously. So it's for me a great pleasure to introduce you to Adam Piotrowski, that today in this presentation will represent the president of Polish Technological Platform on Photonics. And so he will just introduce us a bit about photonics industry in Poland. And I heard already some teasers before, so I'm really curious. So the floor, Adam, is yours.
I'm trying to create a full screen.
Yes,
thank you for
please.
the introduction. And then hopefully I will manage to switch to the other.
You can also go down or in.
Yeah,
there.
It's already there, but I'm not sure.
I see the other screen. Okay. You can also unplug simply the other screen.
Yeah, that's one of the possibilities.
Yes,
right.
There you go.
All right. So welcome everybody from Poland this time. So we are moving just a few hundred kilometers away from Vilnius, and thank you for inviting me to join this great event. And I would like to show you just an overview of what's happening in Poland in photonics and how it's connected to the European market. So using the same icons as Hugo showed, in Poland we are very active in several regions like lasering manufacturing, lots of companies doing material processing, new investments in optical datacom. A lot is happening in photovoltaics right now. It's a huge subject for investors, for Warsaw Stock Exchange, and for public programs to invest in photovoltaics, new materials, and new companies. LED lighting, this is also a huge area for manufacturing in Poland by Polish and multinational companies. One of the largest customer for photonics is defense market in Poland, and components like sensors and optics is also important, and everything is integrated within machine vision supporting all kind of industries that are growing in Poland right now. So my association is employee association. We are just having around 30 members, but it's a combination of the mid-size and small-sized companies, the R&D institutes, universities, and society of scientists. We're mostly concentrated in Warsaw, but with a few members around Poland, and we're trying to make photonics visible in Poland and across the Europe. So we are trying to participate in as many initiatives to create a common knowledge about photonics. So we are continuously collaborating with Polish photonics industry, with Polish universities as PPTF, but also to reach out to other partners. We are having a network of contacts with other clusters working in other industries to do the outreach of photonics to material processing, to energy sector, to automotive or circular economy sector. That's very important for all the photonics companies to go into this direction. Then we are networking with all the European innovation hubs, photonics platforms to create connections between countries, between different groups. And then we are driving the dialogue with European Commission, with Polish Ministry, or local governments in Polish regions. That's really important to represent the individual voices of industry or universities and provide the summary to our governments. So that's an important role of the platform. And then we are trying to do mapping of the companies. Usually the photonics companies are trying to work together, but then they never see the whole landscape, whole the area. So networking, connecting, making companies visible. It's important. Taking them to the trade shows, but also for physical or virtual meetings is also important. So we are doing lots of mapping activities. We just recently went through report, and now I'll show you some of the data. So this is a top 10 OEM electronic photonics companies, and as you can see in red, 5 of them is working with a lot with photonics. 3 of them are in the military regions. 1 is in 4 of them is military. 1 of them is in lightning. And those are just Polish companies, and you can see the revenues in 2019. That's important data to see how the Polish market is growing. But even more important is when we look at companies located in electronic companies located in Poland, but with foreign capital involved. And again, top 3 positions in terms of revenues are photonics companies. LG Electronics, making TV receivers or monitors, Signify, making lightning solutions, and again, displays are very, very important on a Polish map of OEM companies. So that's an interesting how large are those companies working in Poland with us. And when we take statistic numbers, we see lots of from National Statistic Office. We are seeing lots of companies working on different optical components in Poland, but most of the exports is related to displays and lighting. So it's still it seems like our economy is mostly concentrated on displays, but there are more and more large groups of companies like Polish Armament Group, ML System, Fibrain, or Vigo System that are growing, that are creating a Polish position in the map of the components of the photonics elements. So it's really important that it's not just those multinationals, but also Polish companies are active and growing. So here is the revenues together from optoelectronic companies. It's quite a large numbers, starting with military, automotive devices, and then lighting. So it's lots of data and lots of mapping of the companies, of the photonics companies that we can use for further networking and collaboration. In terms of types of components in the supply chain that are manufactured in Poland, the pure photonics companies are starting with manufacturing materials. There's not so many of them. It's amazing because there is quite a lot of research at the universities on materials, but not so many companies. Then more than 30 companies working on components and more working on devices, systems, or photonics applications. So it's important that this pure photonics industry in Poland is quite large and quite interesting and widespread across the supply chain. And we are seeing recently quite a lot of new investments into the photonics companies, and it's across Poland, from Poznań to Warsaw to Bydgoszcz and Rzeszów. Those are companies making like infrared measurement systems, Infotech making specialty fibers, Polon Alpha making gas sensors, Fibaro making smart home equipment. PCO is just finishing their own investment into new building for smart soldier systems and new facility for Semicon and Vigo related to components manufacturing. And also huge investments into the datacom and optical communication systems. One is a purely Polish company, Fibrain in Rzeszów in southern Poland, and right in the middle of Poland, Corning set up a large factory for fiber optics. So lots of investments, lots of interesting activities are happening right now in Poland, and I'm happy to hear that. And still, this all photonics activities, they need to have a support from initiatives like PhotonHUB. And thank you, Hugo, for introduction. And we are having two research partners, Warsaw University of Technology and Institute of Electronic Material Technology, as a second technology partner in PhotonHUB Europe. And they are supporting different technological platforms and doing what is most important for the companies, supporting the training. The photonics is heavily dependent on skills, on people, and this training and demo centers are very important for all of us in the company. So thank you everybody for listening, and I hope you can use a Polish technological platform for photonics as a gateway to Polish photonics.
Thanks a lot, Adam. That was really a great introduction to the Polish situation, let's say, in photonics. That's a really also interesting number to know. And yeah, I guess we have also to learn from EPIC side. We definitely have to engage more with Poland, right? Because let's say there is a question for Gediminas that is to both of us, let's say, because he's saying you have 100 photonics companies just in Mazovia, so I guess the area around Warsaw, right? And your platform has only 20. So seems you're starting integrating the community, right?
Yeah. The Polish citizen is usually a lone soldier, so we don't like to combine too much. So we are using a platform as a group of people who really want to work together, and then we are trying to reach out to all the others, use them. Their discussions, their letters as a base for growing the impact to the ministry. So we are having them, all of them in close contact, but they are not members.
Yeah, but there's definitely a way to get them involved first. I understand that it's also for relatively small companies not easy to always understand the value at the beginning, but that's also for us. So for EPIC, also important to know all these companies that definitely are could be really potential also for at European level. So it's definitely good numbers and a good perspective for both local associations, our European one. So now I would say it's time. So we stick to the agenda once more, and it's time for me to say goodbye. So it was really nice to moderate this session of introduction, to getting to know each other, also from official greetings. So now it's time for the future, so for visions, and it's time for me to give the role of a moderator to Gediminas. So thanks a lot, and have successful session. I believe you will be.
Thank you.
Thank you, Francesca. Now we switch to the second session. It's no break. It's very busy day. So it's, as you see, that in Lithuania we have quite compact community, mainly focused on lasers and lasers, especially for material processing. But we need ideas how to expand our presence in the world, the global laser market. For Poland, it's easy. I have more diversity, but it seems that it's just beginning of integration of the community and to make it more easy. And now we switch to try to provoke our colleagues where we can go to some ideas. And my great pleasure to invite Jose Poza, from Director of Technology and Innovation in EPIC, to make some review trends in photonics.
Thank you very much, Gediminas, for this kind introduction. Thank you. First of all, I would like to congratulate you. You know, in Europe, we have lots of successful photonic ecosystems like Lannion, Palliso, Leuven, Berlin, Jena, Neuchâtel, Eindhoven. I would like to ask all of those to learn to what Lithuania has done, creating an ecosystem, how to align R&D to industrial innovation, how to train people at universities so they fit right the specs for the needs in the industry, how to incubate young companies so they build a supply chain for every company in Lithuania. That's very unique. I haven't seen it. I used to travel 200 days a year before COVID. I never seen this anywhere in the world. So Gediminas and all the Lithuanian industry, congratulations on what you're doing. And Adam from Poland, dziękuję bardzo for what you're doing. It's really quite fascinating. I think you are in the right hands and you learn a bit of what Gediminas and the whole Lithuania has done. Let's do the same thing in Poland. My name is Jose Pozo. I am the CTO of EPIC, which means nothing because it's an association. They don't need a CTO. They just need a person who loves photonics, and I think I fit it right for this job. The purpose of my presentation is to make a review of the trends in photonics 2021. So what I'm going to do is call this Every Photon Counts, and actually more than ever. The previous chairman of the previous session was Francesca Moglia, my colleague, and she already explained what EPIC is, and I don't want to bore you with that. EPIC has almost 700 companies, members, and what we do is to find potential suppliers, partners, and customers in the way of organizing meetings and provide access to market reports. As easy as that, but I'm not here to talk about EPIC. I'm here to talk about photonics. And I love the presentation from Hugo Dimpont this morning. And he said, let's consider 8 digital photonic innovations, right? And he put 8 things there. In my presentation, because Gediminas only gave me 20 minutes, I'm going to focus on the bottom 4 of those. I'm going to talk about lasers, optics for medical, machine vision, and optical components. And mostly showing what I have seen that struck me, that makes me super happy and super excited about this. In the last 3-4 years, LiDAR has been growing dramatically. In the beginning it's a technology that is not new. It's been 20-something years since the first LiDAR system was implemented. But in the last 2-3 years, because of a push from the automotive sector, we have seen a major growth, not only in LiDAR components, but also in enablers of LiDAR components. When we talk about a LiDAR system, for those of you, we're just talking about 3D vision of a car, or 3D vision of a system, actually sweeping a laser to actually take the time of flight of every point. We do illumination, imaging, and photo detection. And all these companies that I'm highlighting here have grown dramatically because of this market segment, because of LiDAR. But what makes me excited about this? What makes me excited about this is something that you're going to hear a lot over this presentation. We are going to the next stage. And every stage in photonics always is an optimization of the previous one in the sense of less optical losses. There's huge developments right now in Europe on developing detectors as efficient as possible. Detectors as efficient as possible, ideally SPAD, single photon array detectors that can actually make sure that we don't lose a single photon. I'm going to come back to that. Another huge trend right now in Europe is wafer level optics for camera manufacturing. What you see here is an EPIC report we purchased from Joel. All the reports that I'm presenting today, the EPIC members have access to the full report, so just contact me, you don't know how to find them. We got quite huge growth on cameras for process monitoring. Cameras for process monitoring was growing dramatically in the last years. And we look a little bit at what happened there. I love this slide. When we look a little bit what happened there, it was all going in the same direction. There is a trend. There is a trend to go into not losing a single photon. Huge innovation is coming. Huge innovation is coming in shortwave infrared detectors and cameras. And it's all supply chain. I'm going to go back to that. You're going to see the link also with industrial manufacturing, a bit of spoilers there. But what I can tell you, what makes Francesca and me most excited of working at EPIC is talking to end users. So we met an end user. This is Marel. Is the market leader in poultry slaughtering. You want to know the numbers? I know I don't want to make you excited about how many poultry they can actually process in 1 hour. I don't want this to be the purpose of the presentation in case there's some vegetarian people here. But they had a challenge. They had a beautiful challenge. You see the chickens there? They're in a surface. They're in a surface, and the biggest problem that we have with a surface is that there is, on one hand, bacterial addition, and on the other, when the chicken is super simple, when the chicken reaches the end of the surface, it has to drop. It cannot be stuck to that. So what we did with them was a fantastic exercise. We brought lots of EPIC members that could help them. On one hand, they needed process monitoring. They need process monitoring to make sure that they have a full characterization of the chicken, but also of the surface that was before the chicken, in case it was properly clean or not. And also they needed surface structuring to make sure they had anti-adhesive, antibacterial properties on the structure. That made us super excited because we realized that the biggest problem, once again, was the detectors and was the idea of integrating them into cameras. And that was a huge interest. What we did was to scout different technologies, many of them. One of them was hyperspectral imaging. For those of you who don't know what hyperspectral imaging is, I'm going to make it super simple. Imagine a camera in which every pixel is an spectrometer. So instead of just taking a pixel, we are taking a whole spectrum per pixel. So imagine just an array of spectrometers, as simple as that. This market, with that simple idea, and with the big challenge of processing all that data real time, of course, has managed to grow dramatically in process monitoring and computer vision. For that particular thing, that now we can actually put cameras like this and have chemical composition detecting real time. And even beyond that, many of you have seen that hyperspectral imaging cameras are now deployed in UAVs and now deployed in agriculture. It is a huge market segment, and new startups are happening every day to go into actually do hyperspectral imaging on chip. So we saw a trend like that, a trend so exciting. What we did was what we do best at EPIC. We organized a meeting with all of them. To asking what was the challenge. And this is the slide that was concluding the meeting. I actually did make that slide for them with their vision. And once again, detectors, short-wave infrared detectors, ideally uncooled, is the biggest need. I will come back to that because it's all with a purpose. But if I talk about the biggest thing that happened in photonics in Europe over the last 5 years, many of you are going to look at the mobile phone. Many of you are going to talk about micro-optics. The micro-optics manufacturing in Europe right now are at the leading of the world. We're actually seeing companies like SUS Micro-Optics or Anterium making the light carpet for the high-end automotive cars. We are seeing also the companies that manufacturing the AR, VR glasses using micro-optics manufacture in Europe, even 3D displays, not only manufacturing, but also equipment. We are seeing technologies that go from the roll-to-roll, roll-to-sheet, and low-cost replication, all the way to photon polymerization. And direct laser writing, maskless lithography-based micro-optic manufacturing is also growing dramatically these days. For these companies, like for example, integrated fiber lasers in Lithuania developing adjustable pulse width in the ultra-fast lasers, this is a huge boom. And these micro-optics are going to be used everywhere. They're going to be used everywhere. Just to give you an example, the medical segment. We are seeing now endoscopy for the first time. Optical endoscopy, fully optical endoscopy, is targeted to be disposable, which means that if you talk about an endoscopy solution, we are talking about an optical fiber with the right packaging, of course, and a microstructure end in which you can integrate functionality. Micro-optics manufactured directly in the fiber. And we are seeing now is that the companies, the large companies, the Olympus and the Karl Storz are targeting this endoscopy, optical endoscopy, to be thrown away after each treatment. That was typical with digital endoscopy, is coming now to optical endoscopy because micro-optics are high-end and low-cost at the same way. One of our EPIC members in endoscopy is the company in Berlin, Art Photonics. And in your previous meeting on that topic, they came up with this idea that there are already a huge growth all the way that biophotonics is larger than information technology for specialty fiber manufacturers in Europe. Already that happening, and that's going to be a huge boom. Unfortunately, this is the medical segment, and the medical segment is not great. It is not. The medical segment is very good for innovation because we are saving lives. But also, you see the innovation that happened in the medical. I had this market report over from Joel, also for free for all the members. And we see lots of beautiful success stories. Look at that slide. We have really lots of beautiful success stories of new medical wearable devices. Really great. Bad news here. Every company in Europe right now who wants to make a transceiver for datacom telecom, they have very easy way of talking to their system integrator and making sure that that transceiver fits that solution. If a company is developing a medical device, a medical module, they rarely can talk to the system integrator. System integrators in the medical technologies, they are because of regulations or because of competition or because of God knows what. They are really not talking to the supply chain. And if people from Abbott and if people from Boston Scientific are listening to me, please tell me that I'm wrong, because I don't think I am. So what they do, the companies developing a medical device in Europe, what they do is they talk directly to the end user, the medical doctor. And they actually try to see if this is interesting for them. And the medical doctor normally tests it. They do the first clinical trial. And if it's better, what do? they write a paper. Because it's a medical doctor, they write a paper. That's how it works, which means that the innovation, the industrial innovation on the medical side is already starting very difficult. Patenting is difficult. We start with a publication. But even more important, if the medical doctor wants it, see the system integrator is not listening to this innovation, we start from scratch developing our own medical system, going through all the FDA approval, which takes normally 10 years of innovation. This is the problem with the medical industry that we are trying to solve at EPIC. And we are hearing good stories as well. So we organize every 3 months a meeting for medical device manufacturers. And we had a nice story. IBM is looking for partners because they had developed a platform. They said, we understand this issue that every company has to start from scratch and develop a 10 years medical instrument because the system integrators are developing everything themselves. So we had this platform fully FDA approved in which we want to have any company that has an idea for a sensing system, sensing module, sensing principle that can be used in the medical. I'm thinking about breath monitoring, I'm thinking about sweat monitoring, I'm thinking about imaging of the skin, I'm thinking about in vitro ultrafast diagnostics for multi-parameter sensing. They have a platform to be integrated to facilitate that FDA approval. And that's just the beginning of what I hope is going to change this industry. We need more success stories like that because the medical innovation is taking now 10 years from proof of concept to medical instrument. And that's devastating. When you look about the different applications, we are talking now about the camera sector in the medical instruments. When we talk about different applications, once again, I'm very happy to see that in this slide, I talk about the different applications in medical and the different technologies. Once again, we are seeing the detectors, the photodiodes, the efficiency of the photodiodes, because every photon counts is limited. I want to also talk a little bit about laser-based manufacturing. I'm not going to talk a lot because in the rest of the session, you have the real experts. I'm just going to tell you what kind of things I found super exciting. And the first thing is in welding. In welding, we saw the presentation from Pablo before, from the PULSATE project. We are seeing a huge push for green wavelengths to be used in copper welding, looking especially at the batteries for e-mobility. That's coming. They are pushing for that. This is the idea. This is the concept, and even Trumpf already has the system. So all these companies developing now laser optics, filters, beam shaping technologies. Look at that. That's a huge boom coming ahead. Green wavelengths for laser welding. But also, system integrators are investing heavily on imaging technologies for real-time process monitoring or laser-based manufacturing. We are seeing how in laser heads, like the one of PRECITEC, there is room for integration of the camera. I'm going to show you how this works. We have here a cooperation between two EPIC members, CEA, LETI, and NIT, and I'm going to show you here in this video, short video of just a few seconds, how we are seeing the laser head manufacturers being able to supply to provide access to SWIR camera manufacturers. And there you go. Here you see how the laser head works. We have now a platform in Europe to integrate any camera especially the SWIR and EWIR region to actually have a proper visualization of any laser-based manufacturing system. In this case, we are talking about the melt pool because this is for additive manufacturing. One more thing about additive manufacturing. Stay tuned for this one. Additive manufacturing is going to boom because now, for the first time, we are seeing companies developing 3D printed of two materials in the same process. We are seeing this coming, already serving the industry, steel and copper being 3D printed at the same time with multi-beam laser solutions. For all the companies in EPIC right now developing laser solutions, stay tuned to this one. That's a huge trend. And also it's a huge trend, the ultra-fast lasers, the pulse tuning, the laser optics, the IBS. But excuse me, because the next speakers are really the experts. So I don't want to use my last minute on this. I want to use my last minute to talk about my passion, quantum technologies. I only have 1 minute left, so I want to tell you that there's huge investment on quantum technologies in Europe right now. Huge investment on that. Everybody knows this. This slide is only a few months old. Look at the billions of euros put in here. I'm working really hard with my team to make sure we make a match between quantum technologies and photonics. For those of you who don't know quantum technology, so just curious, in one sentence, we are for the first time thinking the way that we understand optics and photonics. We are going to study every particle separately. And there are two main applications. There is the ones that are going to do quantum computing with that one, 10, 15 years time to market. Huge market, but a long time. They're going to do quantum operations with these single particles. But there's also the companies who are doing quantum sensors. And this, what they are doing basically is developing, we come back to this, ultra high efficient detectors to make sure they can collect every photon individually. With one of our members, we did something super cool. You're going to love this. With one of our members, we selected all the quantum applications from defense, transport, digital economic, health and space, and we match it with photonic innovations. Photonic innovations needed for quantum technologies. And what we did even more than that, I said, we're going to separate this into two different fields. The fields in quantum timing, in which what we need is very accurate lasers for quantum clocks, and quantum LIDAR, which we need actually very high integration of detectors. I can share this slide with you because it needs hours of thought. We put a lot of hours on this. Thank you, Catapult, for this amazing work. But let me finish with one vision. You see this? I borrowed this slide from Toptica in Munich. You see, this is a beautiful clock. It's a beautiful clock. Like most of the clocks that you guys are wearing, it has an accuracy of 1 second per year to 1 second every 10 years. The best clock you can buy from Rolex, after 10 years, you got to put it 1 second back. This is the accuracy of standard clocks. Look at this. I went to PTV and I saw it myself. This is an atomic clock. It's beautiful, right? You cannot wear it in your wrist, but it's beautiful. It has an accuracy of 1 second over the entire life of the universe. Over the entire life of the universe. You know what is the secret of the sauce in that huge bench? The secret of the sauce? For those physicists in the room, the secret of the sauce is this green line over here. We are actually injecting energy for an atomic transition exactly with a wavelength of 467 nanometers. All the rest are optics to integrate that laser into that system to make an atomic clock with the accuracy of 1 second over the entire life of the universe. So in my mind, there is one clear thing that we have to do with this industry, which is, and Gediminas wants ideas of what to do with this amazing terrain, which is integration. Integration of technologies, optics, detectors, high accuracy detectors that we have now in Europe, laser technology, integrated fiber solutions. We need to go to making these amazing developments that we have now because of the quantum money into real problem solvers today. With this, I would like to remind everyone that if you want to get in touch with end users like me, tomorrow I organize a meeting on fashion and design with companies like Swarovski and Luxottica in the room. And for those of you quantum aficionados like me, on Friday, I have a meeting on quantum technologies for e-mobility. Gediminas, acho, thank you so much for the time. I really enjoyed it myself. I hope you enjoyed it a little bit.
Thank you, Jose. Nice presentation, nice ideas. Most likely for all those examples, most likely this chicken factory, because I saw that all of us can find application for what we are doing. Even we look in one of our projects in this area. I do not see questions from the audience, but maybe we'll continue this discussion when we have more visionaries. And now I would like to pass to Ulrich Göchner from Light Conversion.
Hello, good morning. Okay. So let me start to share the screen. I hope it will work in full mode. Good morning, everybody, once again. Thanks, Gediminas, for the invitation to have a talk about laser industry, and I defined it on the brink to a new phase. And I would like to bring it to you a bit closer, why I think there is a new phase in laser industry for laser source manufacturers mainly. And thanks, Jose, for your presentation before mine, because you will see at the end of my presentation, the last question mark after a word is coming back to your presentation. But I did not modify it. It was just kind of lucky circumstances. So when I will, oops, it is in the center of the presentation. Okay, what I will do, I have to go back just quickly into the years 60s, 70s starting. Then we will have a look at actual innovations. What is the situation in laser industry over the last 10 years?
We do not see you on the full screen.
You cannot.
Can you reconnect your second monitor? Yeah.
Okay, but now you cannot.
Simply shift your slides and. You can simply go through your slides and on the back on the side, left side of the screen.
Okay, good. Okay, once again, we have seen this page already, so let's continue with the next one. Good. Again, I will quickly talk about the history, just only some sentences.
We cannot see your next slide.
You can see my.
We see still first slide here.
Okay.
You're sharing not that screen.
Just a second.
You can simply scroll your slides, pressing by each.
Yeah, I think that's the best. When I go to presentation mode, it switches automatically the other stuff. Okay, sorry for this one. Once again, quick to the past, innovations on a slowdown with a question mark, innovation affects pricing, global markets for laser processing. Then I will talk about change in key drivers, how I see it. Key drivers in the new phase, markets to be addressed, and chances. So, just quickly, 1960s to the 90s. I said, I did start my video. Okay. So, 60s to 90s, the laser technology developed to an industrial level. Majority of the installs, of course, have been up to the 90s, mainly in R&D labs and for scientific. But also, when we go to the beginning of the 90s, where I joined this laser mafia already, first installs we have seen in industrial. Dominant laser technologies at that time have been gas laser, CO2, HENI, but also upcoming these old-fashioned solid-state lasers, lamp pumped, where we did need something like 7 kilowatts for 80 watts of output power. And main industrial applications have been cutting, welding, and marking. Then there is the next phase, which is from 1991 roughly to 2019. What I define as industrial exploitation. That means that the laser technology from a laser source point of view developed further to improve performance, reliability, increasing the field of applications, Also, of course, which is absolutely mandatory when we look at the industry, reduction of cost of ownership. Clearly, with all the installs in industrial, and here we really talk about thousands, 10,000s of units per year for marking business, the industrial installs outweigh by far the installs in R&D labs and scientific. Dominant laser technologies in that area, still gas laser, some part is excimer lasers, solid state lasers, but at the end of the 90s, starting with the 20s, fiber lasers and diode lasers were coming up. Industrial applications, clear, cutting, welding, marking. Within the 90s, medical applications that start, like stent cutting, and the latest thing in industrial applications, I would say, is still micro machining. Innovations on a slowdown. One of the KPIs to have a look at what is going on in innovations is looking at the patents. What is, which patents are granted, which patents are registered. And on some pages on the web page, I found some nice numbers. From 61 to 2000, roughly 20,000 patents in US were granted. In 10 years, from 2001 to 2010, it was roughly 30,000. But the last decade, from 2011 to 2020, it did decrease down to 23,000. So what's going on there? Is there anything changed? Does this peak accelerating annual growth rate comes to a certain saturation? And what we see is a shift in technology. More than 2/3 of the registered patents for laser technology, so more, not application side, but laser core, the core technology, laser source technology, were coming from diode laser technology and fiber laser technology. So not any longer the solid state, disc laser, excimer laser, gas lasers. No, it definitely did move in the last decade to diode laser and fiber laser technology. Looking at and of course, being a sales manager, I always look at average sell price and that stuff. Looking at the core laser technology, CO2, solid state, fiber and diode, we clearly have to state that we are here in the phase of late majority. The fibers and the diodes, there is not that huge amount of innovation. Clear, when we are in scientific, and there is always something new. Also on fiber, there is the arm laser. On diode, you have the VC cells and all that stuff. Then you're again something like an innovator. But the mass in laser industry is using fiber, diode, and solid state, and this is definitely a late majority. Only micro machining with a USP lasers, ultra short pulse lasers. Here I would say we are lucky still being a bit in this early majority, a bit on the peak to go into late majority. But what does it affect? It definitely affects the pricing. Everybody is under price pressure also here, and it is somehow forecasted a price decrease roughly -2, -4% per year. Summarizing the first slides, the global market for laser processing, how did it develop? Up to the 90s, my technology development phase. Here's the exploitation phase, and here's now the big question mark. What happens now? Clear, one is pandemic situation, but when we look at the patents and all that stuff, we also have to see, hey, what's going on here? It's not any longer that a laser source manufacturer can say, hey, okay, I developed something new, something nice, fantastic, and we automatically will find new applications to continue the same growth we had in the past. Change in key drivers. When we look at fiber lasers again, they made a 40% revenue in 2017 and 50% revenue in 2020. So what is the key thing in fiber laser, in my opinion? It is a tool which is expected, which is perceived as kind of fit and forget. And that is the difference to the years before. When you were looking at these solid state lasers, you were trying to modify a laser to find new applications, to tweak the laser to the application, changing mode aperture, changing the degree of doping of crystals, and all that stuff. With a fiber laser, it's not that any longer. Yeah, and subsequently also I mentioned changing laser sources, technologies, the new game-changing laser sources is not there any longer. But what are the key drivers then to keep the level, the continuous average growth rate as up? It is the combination to find new applications together with partners, with external optics. What do I mean? Ways to utilize the higher power levels we can expect. So imagine we have a short pulse laser with 1 or 2 kilowatts, but we somehow have to make sure we can utilize that additional power into speed, because at the end, how to gain additional markets, it is lower cost of ownership at the end to have this process available. Then another one is extend range of wavelengths going into the extreme UV. Use an example, lithography in semicon. Yeah, so Trump is doing an example with this one. Sensors, and I heard it in the other presentations before. We have still applications where maybe a customer would say, yes, okay, great, but how can I make sure that my process is okay? Yeah, sensors, that is the game. Real-time monitoring, validation of processes, and combination with other technologies. Just an example here, when we go into intact printing, yeah, it's done by short pulse lasers, ultra short pulse lasers, but at the end, to have the finest quality, it's a ceramic coating. And I'm absolutely sure and convinced there are many, many more applications around. Markets to be addressed. Of course, we should have a look at those which have an interesting CAGR. Yeah, clearly semicon. What do I see in semicon? Components are getting smaller and smaller. Means shorter wavelengths, new processes. What is about getting rid of chemical things, chemical etching? Can we clean a wafer by laser? There were patents back in last millennium, but nothing did develop. Maybe there is a chance with the new technologies we have. Consumer goods, this was discussed several times today, so I will not step into this one, but I will take it from Rosé. Medical, clear, non-invasive image technology, spectroscopic, surgery things, antibacterial surfaces, treatment with ultra-short pulse lasers, high power, multi-beam things, automotive and also aerospace, anti-ice, friction reduction. Whenever it comes that we are able now to do large area treatments and e-mobility, fuel cells. I'm not talking as a light conversion member from hairpin welding and e-mobility. That is another story. Chances, and I only can more or less repeat what Rosé said, we should find collaborations between laser and other manufacturers along the value chain. Laser source, before you have the material, semiconductor material maybe, but mainly laser source manufacturer, optics manufacturers, sensors. Systems, I mean more the machine builder. And of course, at the end, we have the end user. When we look at the other market, looking at the merger and acquisitions over the last year, it is exactly what large companies are doing. When you look at II-VI, when you look at Coherent, when you look at Lumentum and so on, they are trying to line up, find markets to develop entire solutions. And now coming back to my introduction, I said, you'll see, medical and the question mark here. The statement is clear. Intensify research programs with consortium partners being in the value chain. It does happen in semicon. It does happen in the tools industry. But I barely have seen it in medical. And I wonder what can be done to do it there. So here I have a similar point like you say. There is potential, but we have to see how to bring it up. Yeah. Yeah, that's it. Thank you so far.
Thank you, Ulrich, for your visions.
Issues in the beginning.
Yeah, I do not see question from the audience, and you catch quite different areas of laser application. My provoking questions. Martynas Barkauskas, CEO of Light Conversion, said, one of the goals for Lithuania could be grow from 1% of the industrial laser market globally to 10%. What is the first steps for us?
But when you go to Lithuania, in that case, into Vilnius, I don't see a laser source which can suddenly cover from 1% to 10%. It is the combination of the value chain to find solutions to cover more applications. Yeah, the development, and that is what I try to convey. The development is not any longer that much in a laser source. We have to make sure it is more reliable. Yeah, it is faster. It can do some more stuff. But going from milliseconds to nanoseconds to picoseconds, we are now at femtoseconds. I don't see that going to attosecond will be a big game changer in the laser industry. Not related to scientific, clear, that is another story. But I have learned in the laser industry, when we talk about thousands of units, at the end, certain customers will accept even lower quality when they can say, okay, fit and forget. Yeah, there was some stuff when you take a 20-watt nanosecond pure switched fiber laser, it is a kind of consumable today. You will not repair that stuff. That stuff is just exchanged. Yeah, and that is a game changer, and that's why. It will be definitely difficult to say, okay, I have the idea to go from 1 to 10%. Yeah. So the 1 to 10%, if you say, hey, I'm keen, business is doing something, hey, and I'm supporting it, but then we have to find alliances. Yeah. As a laser source manufacturer alone, no chance. As an optics manufacturer alone, no chance. You have to combine, you have to grow. Yeah, when you look at the other big players, there is a reason. Coherent was always known as just a laser source manufacturer. Look at it now. Look at it where they make their money. It is a complete solution. It is a subsystem. Yeah.
Okay. Now we have a question for Jose. What is your preferred future for the femtosecond lasers? Do we need a reduction of the cost, size, or to address new markets such as data storage?
Data storage is one thing. That's there are two options. We are both in that game. Clear. The size of the unit doesn't matter. I think. We are already reliable. So at the end, it will be standardize this product, reduce further cost of ownership. If a unit is 30 kilograms or 32 kilograms, this doesn't matter.
Okay, thanks, Ulrich.
Thank you.
Now, yeah.
Thanks.
Now we switch to the next. It will be Alvydas Žabolis, one of the founder EXMA company long times ago, and now it's more like working like investor, probably. Yes. Alvydas, floor is yours.
Good day, everyone who participating in this webinar. So, Gediminas asked me to make a presentation for this event, and I asked what presentation about, and because I am not a scientist or so on. And he wrote me, we're a bit stuck with our way to 10 billion. So can you just tell what is your view, how to clean our road? And actually, that was easy and difficult question. The difficult question is how to address you guys, not how to say, not creating walls in your hearts and brains, right? So that's usually difficult, because the message what I want to deal with is very simple, and you will be kind of somehow say it's so simple, right? But you see, I always like this anecdote about the McDonald's founder. When he was 80 years old, he was asked in audience, "What's the secret of your business?" And a secret of our business, it's big smiles and clean toilets. And then someone said, "But it can be done by everyone." Yes, it can be done by everyone.
Probably you would like to share with us.
I will. Be patient, right, Gediminas? That's exactly wall you are bringing now. I'm talking about, right? So I will share my screen, and my presentation is and my topic is today for you is just a bit of provocation for discussion, because even I was at the beginning of this industry in Lithuania. It's still not clear for me. It's a kind of like a handicraft of a business. First of all, I'm talking here on behalf of Snowball, and Snowball is our group company's investment platform, which invests in high-tech, EdTech, and e-com, right? So this team already has more than 25 years of experience of working together, and our view is that we invest into situations or in technologies or which are undergoing or generally market trends which are behaving disruptively, and industries which were like very kind of stable, or there was like a business as usual for last 20 years, and something happened. It is usually our investment object. For example, in EdTech, we are running the biggest EdTech platform in the region, right? And as we investing in the company, we go very deep, and we're not sitting in the board like would do typical investor, but we invest in we're involved in everyday business solution. And for us, we have this expression, skin in the game, right? And what we try to do, we want to get somehow unique knowledge, which usually it's in very talented people, and we want create from those talents and from ideas out of talented people. We want to create a global profitable business. So we want to bring a scale. So we use several partnerships to do the scales, and usually we invest our own funds. We're enough capitalized as for Lithuania. We invest our own funds, but also we invest money of other investors. And part of my presentation will be one of investment stories to tell you how we did. And first I say it's also a bit provocation, because we talk so much about laser industry in Lithuania, but when we look at how to say at more close to the numbers, and we're talking now 150 million euros of sales of all industry, it's a hardly we could be proud that that this is a like industry which dominates in the country. And when we consider that business which doesn't grow 30-40% per year, it should not be considered a business, especially for young companies. Young companies must grow very much significantly, right? So here, when Lithuanian laser industry are being promoted globally as a like a face of Lithuania, but look, here we are, you know, friends. You can call friends on same community. I think we need a bit like to be more critical to ourselves. Are we really growing a business? And basically my presentation, it's just to show our view, my view, how what we're missing and what we can do that really this laser or photonic industry would become not image but real business of our country. Because it's I'm starting talking paradox. For example, all you guys selling everything globally, right? But if I would try to do whatever I can do, but I would not find any foreign investor in laser company, and there was not international merger of acquisition, so nobody bought this business from outside, and you never bought a business outside. So this shows that we're lacking something, right? And here it's a kind of maybe a nasty picture and nasty slide, but my idea is that we're in cultural trap. Because you guys think that you need only two things: research and development and good engineering, right? So that is enough. And I was, when we were told in just previous presentations, guys, a good source with a good technical parameter, it's not enough. It's not enough. And when you see at this picture, this first Lithuanian commercial laser, right? It was this picture done maybe dated 1997 or 1987, right? And this picture I'm still keeping every day in my room, but not because for me like a nostalgia or glory, but for me it's like it's an example of very bad marketing even in this time. So we need more of ecosystem, right? To the engineering and research development, we need to add other competencies, other very important business competencies. And only company which will add those additional competencies, like understanding how to build and implement strategy, how to understand market, how to create a product, not a service, but a product, how to be a world-class marketing machine, right? You know, even if we look at many, I try to find out what kind of CRM system companies using. Guys, we're using like, even if we're using it's something which typical, how to say, there is a kind of manager of, let's say, retail chain already are more advanced. And we're not using financial capital. We're not using investors for accelerating, for scaling, right? Digital level in few companies we just looked currently, it's at the, you know, this, how we call the stone age, right? And stock option plans, it's not here into industry. And I don't think we're being considered by young people as a talent builders. And all this must be, all those competences must be meld together with engineering and research and development into ecosystem. And this should be effective organization. So basically my message is, and probably I can finish my presentation, not to make you more angry, but if we would understand that besides the education in faculty of physics, we need people who understand other aspect of business. That's I think we would break this or we can fulfill this industry dream to become a multi-billion business and to build multi-billion companies. So how to move forward? And to move forward, just repeating myself again, I think current global situation, right? It's absolutely excellent for us because now supply chains will be rebuilt. And all this, one of the, how to say, disadvantages of our sector was that we were far from supply chains ecosystems. Now, when existing supply chains will be or being braked because of transition of investments from China and coming more to US and to Europe, I think we have a chance to participate in this trend. But we need to craft better long-term strategies with higher risk elements. We need these new skills, as I mentioned, including new investors, including mergers, acquisitions. We need to craft our ability to sell better globally, and so on and so on. So I suggest that we look at the sector as with a need to reinvent this business as ecosystem of needed competences. That's actually, it's one of a mission of our company, of this our Snowball platform, because we're investing in the sector by trying to unlock the value. And once we unlock the value in one or two companies, if we make a couple of successful stories, the sky is the limit. Because if one company here introduces some new know-how or some new competences, those competences will spread through all our ecosystem of us or two other companies very quick. I'm looking at my time, so I still have about 10 minutes left. And I now will go maybe to one, you can say, investment case, right? So, so this investment case, it's a well known in Lithuania, but as I see the guys also from other countries, I would like to tell this story, right? So there was two brothers who came from education. So actually they started at Vilnius University, so then they went to Sweden, then to Germany, then when they finished PhDs, and they came here in 2011, and I met them first time in 2011, and they were looking for the capital to buy this epitaxy technology because they tried to create a new kind of platform, semiconductor platform, and I said, look, there is no capital for your investments here in the region, and probably you need to start as usually from or Institute of Physics, then it was, or like now FMTC or so on. But those guys had ambition, and they were going through several investors, and they were lucky because in this time there was a first European investment fund-based funds. So I mean EIB-based funds, and there was a European Union programs, and they got a capital to build a facility. So they built facility, and they try to be a service providers. I mean, to grow those structures for the companies, for other who invest, who would use them in experiments and so on. And it's really was not working. They ran out of funds. And the venture capital fund, which was sponsoring them, was not able to invest, but also the strategy was not working. So they they understood the need that I cannot be a service provider. I cannot be only, creating something. I need to come to the product, to the final product, right? Product which will have a user, and I need to go all this painful way to create a product. So there was a consortium of investors was built with participation of Light Conversion and Romas Danielius, and this consortium bought out this VC capital. And that was also unique because the guys never had any equity in the company. So the three brothers, they were only employees of this company, and they had a kind of promise from venture capital guys that once they will pay capital with annual rate of something like 45%, they could pretend in some equity premium. So what we did, and I'm really think that it was a good step by this investment consortium, because we bought from this VC company 50% for brothers and 50% for investors. So it means we created immediately owners, or we made them equity holders in this company. And I think this was a step to unlock initiative, unlock creativity even to new level. And company started, they made a first application for defense, and now there is many systems sold for defense. But this is not where story ends. So in fact, now they're developing, as was told in previous presentations, something, it's a spectrometer. Spectrometer will be, it's already a prototype, it's worked, and it's already distributed to producers, and will be like a 4 by 2 by 1 millimeters sensor. Or in fact, it's a sensor, it's a spectrometer and detector, and and this way how the product will be built for medical applications and for wearable, right? So this is now attempt to build a new generation sensing company. Investments or capital needed to develop, it's enormous. So now we are raising first round, which will be 15 million euros to invest, for the final proof of concept until the production. And for mass production, we need to invest something more close to 100 million. And question is where such level of capital, whether such level of capital exists in Lithuania to invest. So our solution is that it's an excellent time, not only for this company, for every company in Lithuania, because or in the region, because we have this new strategy also in European Union, and the strategy is that we need to invest as European Union looking investments besides the climate change to digital technologies, and generally to technologies, to innovation and health technologies. Also it's a high priority. So in fact, there is a lot of quasi-equity currently being built in institutions like EBRD, like EIB, European Investment Funds. There will be, it's a different product. It's a different product compared to those European grants, which you guys already are very familiar how to get. To get money from those institutions and mentioned, it's a much more, bigger challenge, because, frankly saying, the papers you are writing for this European grants, especially in Lithuania, doesn't require much of really business approach. If you want to make application for those financial institutions, they have a very high requirements for the actually for the vision, for the business plan, for competences you have in your companies. But I think it's only way how our sector could reinvent itself. So by ending my presentation, so we used a proposal of organizers, and we created this virtual chat room. I don't know when it will be open, probably when the program says networking session, but please meet our Snowball team. Will wait and maybe can give to you some hints or ideas about development of the sector. And I think I will, as I was requested, I will finish my 15 minutes and leave few minutes to question session.
Thank you, Arvydas. Is a potential human resources infrastructure strategic goals to push the Lithuanian photonics sector from dominant development of components and laser sources more into integrating offering and customer photonic related solutions?
Yes.
It's a very short question, yeah?
No, of course, it's why to talk, yes or no, right? Yes.
So you see this area that one of we can expand our presence in not only in laser but mainly in photonics.
Gediminas, I think it's, when you have a will, and if you have some right competences, you can do whatever you can dream of, right? And this our whole sector was created from dream, right? And it's absolutely from dream. And now Kęstutis will take floor and explain. But I don't know where people know or not, when we built this laser, when I showed this picture, and then we said we were young and we were trying to say what kind of dream we can create that we cannot fulfill in our life, right? So then we were sitting in sauna, because those time sauna was a kind of like a good time to spend your free time. And me, Kęstutis, and other guys say, guys, what we can do? And then we said, can we make a system or laser which we would be able to sell to Japan? Because for us, Japan in 1987 was something like a magic we will never reach, because we were still in Soviet system. And this was a joke, right? It was a joke, but this joke touched, I think, our hearts and our general intellectual pride. And 1991 or 1992 was a time when the first laser was sold in Japan. So I think we can do many things, but the problem is that we guys left in this 1991. The world moved and we're still sitting in this sauna. We need to lose our comfort. We need to shoot, if not into one leg, maybe in two legs. And we need to wake up, because sector will die in few years if sector will not reinvent itself. That's a promise. And okay, you maybe will not like it, but that's my message to you guys.
Yeah, it's really was my idea for the session, to provoke all of this our community, that we should work on new ideas that can consolidate more of us, looking more broader. Okay, thank you, Alvinas. Now we go to the next presentation. It will be by Kęstutis Jasiūnas, CEO from Expla company, about future of high-intensity lasers. Kęstutis, floor is yours.
Yeah, thanks, Gediminas. After such impressive speech of Alvydas, it'll be more difficult to talk. Just I try to share my presentation.
No, it's okay.
So now it's okay. So you can see my presentation. So Alvydas has talked about snowball in business. I will try to return back to the technology, and I will talk about surfing on the waves. So it is a little bit different. But Alvydas is right. We are more technology people, and we're sitting in technology level, not in the business level, maybe more or less. So I'm going to talk about surfing on the waves. You can say crazy talks. We don't have ocean with real waves, only calm Baltic Sea near Lithuania. And the conference is about photonic future, not about adventures. But you always dream, as Valdas told, this dream about what you are missing, about something not realistic. And in our case, then you can fly to Canarias for surfing, because it's Corona now, but you can create some alternative. So I'm going to talk about surfing not in the ocean, not in the water. I'm going to talk about waves in the different state of matter, about waves in plasma. And those waves are not caused by wind. They are created by ultra-short, ultra-high intensity laser beams. And the surface of these waves are charged particles like electrons, protons, ions. And it will be talk about one example of promising future technology, and about something dreaming, what can be dreamed. Maybe it's not reachable in our life level, but I think it's reachable. So, and it's more important, it's not talk about producing of lasers, it's about of using of lasers in some technology. And I touched this technology. It's like a boat sails in the lake and water waves forms behind him. So, and as bigger and as fast a boat is sailing, the bigger waves we have behind. And in the other side, there is powerful laser fires and ultra-short, high-intensity pulse into a matter, wake it, and induce a plasma waves. And for laser plasma wake field acceleration, an intense laser pulse is focusing into a gas. The rising edge of the laser beam pulse ionize the gas and create a plasma. And as the laser pulses propagates in the plasma, the electrons are expelled from the optical axis, thus forming a cavity free of electrons in the laser wake. An electrical field in this cavity has a very large amplitudes, up to hundreds of gigaelectronvolts per meter. Charged particles, that is coming from plasma itself or is injected from outside, can surf on this crest of waves and accelerated by its strong electric field. It looks very simple, but there are a lot of technological challenges could be solved. Not only technological, but as well as application challenges before applying to real particle acceleration. When we think of particle accelerators, machine which accelerate charged particles to almost a speed of light, we tend to think of a Large Hadron Collider at CERN, largest machine ever built by humans. It's one example of humans' dreams realized. But More than 30,000 particle accelerators in operation worldwide today. Only about 10% are used for scientific research, and only 1% specifically in high energy particle physics. So what are rest used for? In this table, we can find all applications and how many systems are installed in which applications. There are well-established commercial applications like electron and photon, cancer therapy, ion implantation, radioisotope production, electron beam material processing. And there is new commercial applications under development like proton and ion cancer therapy, neutron generation, ion beam analysis, and others. And as you can see from the table, the majority systems are installed for medical purposes, for cancer treatment. Nonetheless, for industrial application, such as ion implantation or material processing, the market for medical and industrial particle accelerators currently exceeds $5.5 billion per year, and it's growing up to 10% annually. All digital electronics now depend on particle beams for ion implantation, creating $2.5 billion annual market for ion beam accelerators. All the products what are treated or inspected by particle beams have collective annual value of more than $500 billion. It's a huge market. Almost all of the accelerators used for these applications rely on technology developed nearly a century ago. Most current accelerators are used structure called a radio frequency cavity. You can see in this picture. The cavity transfers electromagnetic energy into kinetic energy of particles by accelerating them. However, there is a limit to the amount of energy what a radio frequency cavity can transfer to particles. This is because despite of operating in vacuum, there is a risk that increasing the electromagnetic field can lead to lightning-like discharges of energy. In this case, it is necessary to increase size of such accelerators to achieve a needful energy level, or to multiply such cavities like in 27 kilometers circle like a Large Hadron. This technology and possibility to increase a size of system led scientists to achieve hundreds of thousands gigaelectron volt necessary for physicists, like in Large Hadron Collider. But for commercial usage, those big, inefficient in energy consumption, expensive systems limit their affordable usage. Such machines is about a 10-meter tall, cost more than $4 million, and need to be replaced every 5 or so years. Their size makes them hard to maintain, as well as hard to maneuver around the person's body. Scientists and engineers are looking for possibilities to develop compact, with low energy consumption and relatively inexpensive tabletop particle accelerators for medical and industrial application. So now it's time to return to the surfing on the waves. The idea of tabletop wake-field accelerator was described the first time in late 70s. But first experiments was made in late 90s with the development of laser technology. Idea was an intense ultra-short laser pulse is firing into a plasma and driving the particles forward, while ions are much heavier and much slower than electrons. And they separate out into two groups as they move. So, as they push forward, the trailing electric field, so-called wake field, develops behind them. This field has a very large amplitudes, up to hundreds of gigavolts per meter. The linear accelerator, like at the Stanford Linear Accelerator, SLAC, can manage from 7 to 800 megavolts per meter. So, if it had to energize a particle from 0 to 10 giga-electron volt, it will need to accelerate the particles around 14 meters. Circular accelerators, like in Large Hadron, have gradient only about 250 megavolts per meter. If to compare, a Wakefield accelerator can achieve from 10 to 100 gigavolts per meter. The team from Lawrence Berkeley National Laboratory has managed to speed subatomic particles to energy of up to more than 4 giga-electron volts inside a 9 centimeter log tube of plasma. The problem is that this laser-induced plasma wake field can only sustain over a very short distance in order of few centimeters, maximum up to 10 centimeters. This means it can accelerate a particle only to few giga-electron volts. But in fact, lower energies are more important in some contexts. As you can notice from table shown before, majority of medical instruments operate in sub-giga-electron volt level. A third generation medical linear accelerators energize electrons to about 20 megaelectron volt and cost more than $4 million. A Wakefield machine could potentially reduce this cost, as well as size and energy consumption, where it will become more accessible to doctors, medical researchers, and industry application. But for all of this, we need a suitable laser. According to publications, number of which has been growing over the past decades, and patterns is growing as well. For laser plasma Wakefield particles acceleration, necessary to have ultra-short pulses starting from few terawatt. Necessary to have state-of-art laser system which peak power ranging from few terawatt to petawatt. As you see, invention of CPA at mid-80s and OPCPA at beginning of 90s, actually OPCPA was invented in Vilnius University, opened the gate for further achievement in high intensity level. Starting from first 500 terawatt shot at National Ignition Facility in 2012, the lot of ultra-high intensity laser facilities was installed in scientific laboratories. There is more than 100 facilities with ultra-high intensity lasers around the world. You can find few of them in our region, one in Vilnius University, a few of them is in Poland. But what is even more important, we have producers of such system in Lithuania. To count all companies exploring such technology and capabilities, enough fingers on your hand. Two Lithuanian companies with support of scientists of Vilnius University installed first terawatt system Naglis at Vilnius University on 2014. After 5 years, we succeeded to install 4.5 terawatt system at ELI facility in Szeged in Hungary. The biggest challenge was not only terawatt pulse level. The biggest challenge was such powerful laser operate at 1 kilohertz repetition rate. Almost majority of ultra-high pulse laser systems around the world operating at low repetition rate. You can reconcile that if you do scientific experiments, but for commercial application, things have to be done fast. Few months ago, we have signed contract for 3 times more powerful system, which should be installed in 2022 in the same Szeged. One of the main tasks of the system's customer will be investigation in plasma Wakefield acceleration. We at Baltic Sea have possibility to create waves suitable for surfing. We have a good lasers suitable for wake-field waves. We have specialists in particle physics. We at Lithuania still a nuclear country with a necessary infrastructure, and we can invest in promising future technology. There is necessary to have starting support for technological concept development at our R&D institutions, and to have for startups to start a new promising high added value business direction. So now we're shooting Corona with how is in English, with spritz, but it's better to shoot Corona with subatomic particles. Thank you.
Thank you, Kęstutis. Are there any questions? I do not see in the pool. It's when we can have this kind of a laser that's like industrial grade, but you can share to the customers like doctors that it will be not needed to have few engineers, 2 professors to manage this kind of the lasers.
Yeah, but this task needs to have a real user, industrial user for that laser, because now our users is scientists, we're professors, and it's not necessary to develop this laser to industrial grade. Mm-hmm. But to get knowledge what about industrial users, about needs of industrial users, you should have contacted them in reality and to do laser for their task. So it's difficult to say.
Okay, thank you. Probably I told for somebody that we are, as researchers, are involved in some new European projects with doing some X-ray machines for customs on the border, using the laser wake field acceleration. So it's really one of those tools that will be tested. It will be Silos laser in Szeged. So it's some chance to have some insight from industry on this kind of the laser.
Yeah, it will be great. It will be great.
Okay, thank you. And now move to Poland. And back to more from solid state lasers to semiconductors devices, and we have Jerzy Lach from Vigo Systems about infrared photosensor for digital industry transformations. Jerzy, floor is yours.
Hello, everybody. Do you see my screen?
Yes.
Okay. Hello, everybody. My name is Jerzy Lach. I am application engineer at Vigo System. It is a big pleasure to be here and to present you some information about Vigo Systems company and products and plans for the future. I hope we can maybe have some common points for future cooperation. Okay, so who we are and what do we do in the market? The company was founded in 1987. We were grown based on photon detectors invented by our founders, and our company were developing that detectors over the time, and recently we founded EPI foundry with 3.5 materials and other compounds, and we are trying to cover more fields in the photonics. So the company consists of over 170 employees, and we started new facilities, so we extended our capability of production. We send few detectors for Mars Science Laboratory. So we have in-house unique technology and R&D capabilities So we try to keep all of our production and research and development in-house. So company is driven also for custom fit solutions for customers, like custom-made detectors and systems. Also, we gather highly educated personnel, including 2 professors at this moment, and a lot of PhDs, and more than 60 engineers which are developing the detectors and systems here. So, short history of company. Over the time, we were constantly growing, and up to now, we are in a new production site, which is able to produce over 100,000 detectors annually. So we try to reach more fields of the market besides of the still the detectors. We are cooperating to a lot of famous companies in the market, like those, as you can see here. Also, we are cooperating to a lot of scientific institutions in Europe and over the world. And the market share of our sales is mainly in Europe, but we are present in other continents like North America and Asia. So we are trying to cover all of the markets. The production capacity of Vigo system includes, as I mentioned, all in-house production and R&D from scratch, from epitaxy to complete systems, integrated electronics with the detectors packaging, and recently EpiFoundry, which produces the epitaxial wafers, which are offered to the end customers. The epi wafers can be used at our customer site for QCS, VCSELs. So those companies who are attending today, I mean laser companies, commonly use epi wafers to make lasers as final products. So we are open for every epitaxial compounds what you are in your mind. So we are open for discussion about the compounds and making processing of them. Briefly speaking about our current products, we are covering almost all known infrared spectral band from short infrared to far infrared, let's say from 1 to 16 microns of spectral range. Our company were grown on MCT material, but recently, in recent years, we started to make detectors based on 3-5 materials like indium arsenide or indium arsenide selenide detectors. And we are producing also dedicated electronics and trying to build this custom-made systems for our customers. The new products based on 3-5 materials, in this case, are medium and long wavelength infrared detectors as a super lattice materials, because we try to be in the game, in the market, in terms of OHS compliant market, due to probably stopping production of MCT and other similar materials. This detector is comparable to liquid nitrogen cooled detectors which are offered in the market. So we hope we can satisfy the customers, especially of those who are interested in long wavelength infrared. Other interesting products for laser, the laser companies could be quadrant geometry detectors, like you can see here, which consist of 4-pixel architecture, and you can position the beam or measure the parameters of the beam of the laser. So these detectors can be used in the laser applications. And the last one interesting product is a multi-element detector. As you can see on the bottom of the screen, this is exemplary application of the 2x16 pixel orientation detector with integrated electronics, which can be used in various nice applications like spectroscopy, detection of the thermal sources, and so on. What we plan to do in the future? Of course, according to company growth, we plan to increase our fields of the market, not only be in detectors, but also in epi wafers, being epi foundry, and we try to make microsystems like arrays, as you saw on previous slide, and we plan to make some small matrices, and in the nearest future we plan to reach the project with chip-on carriers and chips with ASICs, means dedicated electronics integrated with the detectors. And our hope and our plan is to have detectors or systems with digital output for IoT standards, because this is trending in the market. We see that a scale of integration is growing and growing over years. So we want to be also in this game. So we plan to make integration scale higher. Here you can see the typical applications of infrared detections, like active beam sensors, the sorting solutions to recognize the particles on the sorting lines, gas analysis in general, as you can see on the chart, and motion sensors like on the railway, the detection of hot boxes in the trains, which are mounted on the bottom of the track, on the bottom underneath the train. Also for epi wafers, we are targeting the markets like commonly known in the infrared applications like VCSELs, QCS, lasers, common detectors, transistors, diodes, and in the meaning of 3.5 materials or MCT, it is healthcare, transportation, defense and security, and environmental protection. Of course, VIGO system is very open for discussion about the projects which integrates all of parts from photonics, including the laser or other sources, the detectors, and everything which is behind the source and the detector. And of course, it's driving us to make a photonic integrated chip, which is in plans of the company. So we are open for discussion about the ideas and thoughts in this field. So we are very open for that. Thank you for your attention.
Thank you, Jerzy. I do not see a question from the audience. My question, do you have customers in Lithuania, and how we can exchange, enhance this collaboration?
Currently, I think not, but we are open for customers in Lithuania. So,
because we have quite a few companies that working on lasers and middle infrared, so it's really they need somehow to be detected. One thing.
Just make a call to us, or
yeah. And another area, as Jose also mentioned, it's infrared area, mid-infrared is very interesting for industrial monitoring, especially when heat treatment happens. It's laser processing also as well. Oh, it's Jose, it's now. So would like to join for that? No?
Yes, I would like to jump on this. So the vision from Vigo system has been to develop a huge platform for making the best detectors in the world for mid-infrared sensing. In many of your applications, you are targeting systems that includes quantum cascade lasers. And today they are very expensive. Is there a need, a trend, a particular challenge that you would like to present to the EPIC members in terms of cost reduction to make the dream of Vigo come true?
Okay, thank you. If there are no more questions at the moment, thank you all those speakers of those two sessions. Now we have nearly 1 hour break, but please press a button networking. We will meet in a very exciting site. We can communicate a little until we go to fill our coffee. And we meet at 2 o'clock in Lithuanian time. Okay? See you in the networking area.
So, welcome, ladies and gentlemen. My name is Julius Paužuolis. I'm director of the Science and Technology Park here. So, welcome, ladies and gentlemen. My name is Julius Paužuolis. I'm director of the Science and Technology Park here. So, welcome, ladies and gentlemen, and I will guide you through the next 2 hours. And now we are having very important part, about the essentials how to apply, how to apply in these open calls, Yes, and we have here a wonderful organization, funding box. And we have a senior project manager, Ms. Izabela Zrazinska, and she will tell us how hard or how easy to apply, in this open calls and how to get something from this funding box. So Izabela, the floor is yours.
Hello, thank you, Julius. Thank you for the opportunity to present the PULSATE open call. So first of all, well, as you know, this is very related to today's session because PULSATE project that was presented today earlier by project coordinator, Ayman, is also giving the opportunity to the SMEs, so the small enterprises, into adoption of the laser-based advanced and additive manufacturing technology in the production environments. So I would like to briefly tell you about who is this open call dedicated for, this support, what are the benefits. Also, we'll pass briefly about the selection process, and I will give you also some tips on how to write the proposal. And at the end, we'll have 10 minutes for questions before the next presentation of the PhotonHUB project. So briefly, I was already introduced. So I'm the senior project manager at Funding Box. Here in the PULSATE, I'm the open call manager, and also I support the project with the dissemination. And I represent Funding Box, which is responsible here for the open calls. We do it in many projects, and we are like one of the biggest deep tech ecosystem in Europe. And our main goal is to connect the companies, to the SMEs, with the corporates, with the investors, and with the ecosystem, and create so-called funding champions deal. And we do it for not only, but also for the European projects with different domains. And here with PULSATE, we are under I4MS initiative for manufacturing industry. And now to the point for the PULSATE open call. So the project lasts 4 years, and we will organize 4 open calls during the duration with the goal to select 62 projects with the total budget of 4 million euro. And we'll have 2 types of the open calls. So the first one, I would say the main one, because this is the biggest ones, are the technology transfer experiments. And those are for the consortia. So this is the open call that I will actually tell you a little bit more today, because this is the one that is launched, that has launched in February, and the deadline is by 22nd of April. And then we also have the second type of the open calls, the shorter ones that we call adopter use cases, where we'll select on individual companies, SMEs or slightly bigger, that will support with performing technical and economical feasibility study during 3 months. So it's a short support program with the grant of 25,000 to check the adoption of this model. The experiments are much longer because actually we'll also support them technically with this adoption and experiment. And all the open calls, well, the updates you can see on our open call landing page. And for the technology transfer open call that has launched now, what is provided in the support program, so selected experiments will enter to the 12-month support program. Okay, so as you can see, it is divided by stages needed to develop each part of the experiment. So the first one is the technical development, where Technical support will be provided by the competence centers. We have 6 of them in the PULSATE project that will be responsible for providing the support and guidance to develop the technology in the first 6 months in order to reach the proof of concept, which is the second stage, where the adopters, okay, that is why we are looking for consortia. So in the stage 2, the adopters, they will work with the technology provider on actually implementing that technology into their production environments. And then at the end, we'll have a short stage, scalability, to bring everything up to the market, to look for the further investment and to scale the experiment. Also, well, there is a funding, as I mentioned, it's up to 150,000 per experiment. And of course, through the open call and through the PULSATE project, you will be exposed to the European industry, to the investors. You also get connected with the business mentors. So there are a lot of benefits during 1 year that will bring this experiment to the higher level of technology, but also business. Here are the technologies that are available. I will not tell a lot about it. I invite you all to go to our guide for applicants. Okay, there is a list of the competences that each of the research centers involved in our consortium have. Here are only the examples and domains that are covered by this open call. And also, well, just to tell you that it's also about the processes, but also the equipment that could apply. So here are also some ideas on the research or the experiment that could be covered by your proposal that you will submit to the PULSATE open call. And who can apply? Maybe that's one of the important parts. So as I mentioned before, we are looking for the consortia to perform this experiment. So for sure, you need someone that has the innovation, the technology provider, and you need the manufacturing company, or how we call it, end user or adopter. Okay, so someone where this technology will be actually implemented in this production environment. And what is important is that both entities, a technology provider or manufacturing company, need to have the SME or slightly bigger status. Okay, so this is very important that the support goes to these 2 legal type of entities that should apply together. And in case if you do not have a partner to apply with, you are looking for innovation to boost your process, or you are actually looking for the adopter to apply your technology, then you can submit. We have a very short form where we try to help those standalone SMEs to find and match with the partners, or you can also write a post in our matchmaking community. And the last minute chance also, because this Friday we'll have the matchmaking event, so you can still register and then you can pitch shortly your solution or your idea, and that is actually the most effective way to get matched. So this is still ongoing, and you can register for Friday event. And then shortly about the SMEs and slightly bigger, sometimes for those that are not experienced in applying to European projects, this might be new. So there are 2 things that you should just check that are the main requirements when checking this status. So one is the headcount. Okay, so the maximum is 500 people hired basically in your company, and then also the annual turnover. So the top one for the slightly bigger is less or equal to 100 million euro. That you should check before applying. Okay, if you have a SME or slightly bigger status, you can of course also check the European Commission references. And also please always remember when checking that if you are the subsidiary of the bigger group or company, please also check if that's because sometimes that also applies to your status. And then, well, the requirement, as we are European founded project, so of course you should be located in Europe or in associated countries. Also, UK is eligible if you ask. So please check. This is also important. All the consortium members that apply have to be comply with this criteria. And then the areas of experimentation that were predefined by the PULSATE consortium. So these are 1, 2, 3, 4, 5 areas. You need to, in your application form, in the excellence section, you should try to describe your experiment so it refers to one of these areas. Okay, so as the PULSATE project has influence on the whole laser industry, we want to make sure that through these areas, actually, the challenges will be overcome. Okay, so please, also written guide for applicants. There are some examples that you can actually see what is meant by each of these areas, but at least one has to be reflected in your application. And then also the TRL level is the TRL 5. So your technology should be validated in some relevant environment. Okay, so this is important. This will be also reviewed by evaluators. Okay, so there is a section also in the application form where you should briefly describe your technology and actually also try to prove or well to confirm that this is the TRL level, this is the correct TRL level. And the minimum is 5, and also it's worth mentioning about maximum, because also we would like to support the companies that really need that and that actually need that boost. Okay, so that is why the TRL 7 is the maximum TRL that you can have. And then, well, just the summary here. About the requirements, if your proposal is in the middle, if you have a consortium made by SMEs or slightly bigger companies that are located in Europe or associated or UK, if at least one company that you will apply with is the manufacturing SME or so-called end user or adopter, that is also very important. If you should also remember about the experimentation area, reflect or at least one, and about the TRL level from 5 to 7. So as a summary, these are the eligibility criteria that if you accomplish them or if you, then you are eligible. And then how? If you're wondering what is the selection process, it's also quite easy. The application form is, well, we try to make it as short as possible, ask you only for necessary details. You can apply through this link. Okay, this is the application website. And what's worth mentioning that before you can actually click apply button and just to see the evaluation form, you don't have to submit if you are not sure, but with apply now you can just open it to see the content. And then we always recommend to go to guides and documents section. There is a guide for applicants, which is like the very important document that you should start from, okay, when you plan to applying. But also there are some supportive documents like frequently asked questions or also our webinars that you can join to ask more questions and to improve your application. And the selection process, as I mentioned, the deadline to apply is 22nd of April. So please remember, this is the final deadline. Then in the next, once we close the open call, we will pass the applications that are eligible to the experts evaluation. And this is like the most important part that lasts 3 weeks, where 2 independent experts from the industry will evaluate all the proposals and will establish the ranking based on which the decision will be made. Okay. Later we have, of course, the consensus meeting. So that's when the consortium will just validate the selection, and we'll have the jury day, which for now we already know that it will be online on 10th and 11th of June. Okay. So that is one where you will just pitch, your experiment, and the consortium will ask you some questions just to make sure and cut off for the finalist, okay, that will sign the agreement with the consortium and that will enter the support program. And for the application form, I just would like to briefly tell you about the 3 sections, not getting into too much details, but these are the ones that will be evaluated by external experts. So that is The rest are more the content, or well, the contact information, or the the GDPR things. So these are the 3 ones that you should focus on, and actually they are described in details also in guide for applicants. So for the excellence, we'll ask you for the technology. Okay, so what is behind this experiment? Also, you should prove that you have the required TRL level. Okay, that will be verified through this form. You should reflect this one of experimentation areas that I mentioned earlier, and also show the state of art, okay, related to this application. So more, if you can show the technological novelty, then this is actually bringing more chance that you'll be selected. Then in the impact section, it's more focus on the market. Okay, so of course you will apply with already one end user. That is the requirement to be eligible. But if you can show that this technology that you apply with is scalable to the different industry, that will also bring the added value to the application, right? That it is applicable to different industries. And that also shows the market potential. And you should not forget about the competition, if there is any. We would also like to hear about your initial business model on how to bring this to the market. And if you have any connection with the academia and industry, like you create the new product, found new company, you plan to apply for a patent, then also this is an important part of this section. And also, well, there are small additional points for the environmental, equal opportunities and social impacts that are always well seen in the European projects. And then the final one is the implementation. I would say it's the most difficult one because you need to plan a little bit the experiment that the experiment that you will perform. So you have to think about main actions that you would like to perform within the support program per stages, which I described earlier. So you should list the tasks, like the main tasks at least, that you are thinking to perform. Also about the KPIs, so what would you like to reach with the support of the PULSATE project? And well, more measurable, relevant and ambitious they are, and realistic actually, then better. Then of course, if you foresee any risks and you already know how to mitigate them, that will also be valuable. Also, don't be shy to tell us what do you need. Actually, if there's some crucial things that will be needed to perform the experiment, like facilities or some specialized staff, then also included in the application form. And you can also try to reflect on the list of competences that is included in our guide. Then consortium team, so who is behind the experiment, what is the experience of the people, that is also crucial, and the budget. For the budget, also just few details. I will not get too deep into that, but there are the typical 3 categories: personnel that will be engaged, travel, and consumables, so that you will use for the experiment. Okay. And then we have included, well, there you have to calculate from this the overheads, and also if you plan to subcontract someone, so like delegate one of the tasks of the experiment, you should also include this, and then you will have a total costs, and you'll be able to calculate the requested amount. And what is important here is that the funding rate is 70% of the total costs. Okay, so this is important to take into account, and for more details, we invite you to read to see the references of this cost and example of such a budget in the frequently asked questions. That will for sure help you to understand these categories if you haven't done it before. And also it's worth remembering about a maximum limit. So there is, of course, up to 150,000 per whole experiment. But also there is a limit of 100,000 euro per company in all the PULSATE open calls, okay, and actually in this one as well. But also you should remember about the I4MS project and also CAE open calls. So if any of the companies that are involved in your experiment are beneficiaries of the I4MS or CAE open calls, this limit also applies. Okay, so this is also important to remember about. And that's it from the details that I think is worth sharing. If you need any help, you can send us an email. We also have the open call help desk where it's a chat, public chat where everyone can ask questions. And as I mentioned on the guides and documents sections, there are many tools to help you and through which you can reach us out. And I believe that's it. If there are any questions for now, then I will be glad to answer them.
Okay, thank you, Isabella, a lot for your, clear presentation, what to do. And actually, yes, we have a couple of questions. People are interesting. So question number 1 from Mr. Jonas Bulaitis is what contribution for the project should be from the companies, or what is the funding rate?
Mm-hmm. Well, what we expect from the beneficiaries is that they implement the technology into the production environments. Okay, so this is the main outcome that we want to show. Okay, that this laser-based additive and advanced manufacturing technology can be implemented into industry and to the different sectors. Okay, so that is the main outcome. I'm not sure if that's.
Yes, but yes, okay, that's very great. But what is the funding rate? Is it 70% as you showed? Yes,
it's 70%. Yeah.
Yeah. Okay. Thank you. The next question from Miss Kristina Ananichene. So, can company apply from any sector, or it's focused on some sectors, specific?
Yes, we do not focus, as for the industrial sectors, we do not focus. The PULSATE project indeed has some that we identify that we would like to reach, like the textile one or automotive, but we are not limiting it. Okay, so this is just to tell you that PULSATE as it is would like to reach some of them, but we are open for all. So there is no minimum for that. We're open for all sectors.
And thank you. Another one question. Can SMEs be from the same country, the whole consortium?
Yes, they can be from the same country.
Okay, yes, no more questions I see, so maybe I ask from my side, just off topic, do the companies, feel happy participating in these open calls and getting support, for this innovation from Funding Box?
Yes, definitely. Well, we are engaged in many open calls like this one, and I have to say, of course, in PULSATE especially, the team is very strong. So this is really, the companies are very happy to be able to work like with the research centers. So that is something that usually SMEs have a barrier, that it's very difficult to reach the research centers, that they're working on different things. So this is a big plus. Of course, funding is a big plus because it helps you, to focus on actually technology development because you have the money for it. You don't have to do the fundraising. So this is also very helpful. And also the business mentoring that in PULSATE is provided by Funding Box. It also helps to rethink sometimes the business models and how to approach the market. So at the end, I think, they are happy to participate. And here, I think the chance to get accepted is quite high. So I invite everyone to apply and to give it a try.
Okay, thank you. So we have a couple of minutes of time. So I will ask you another one question. How are you planning? How do you see? Will it be the very high competition in this forthcoming call? How many applications to one
Yes, I mean, I'm not allowed to tell how many applications we have for now, but of course, the laser-based, the LBMM technology is not that popular that AI, for instance. So of course, we expect the moderate number of applications, and that is why I think that the chance to be selected is bigger, of course. So that is why this is also a big plus for this. But of course, the difficulty is that you have to apply as consortia, at least to this technology transfer experiments open call. And that is where we are trying to do matching with the PULSATE team between all the companies that sometimes don't have the partner to apply with, right? So that is why we have this matchmaking webinar, but also sometimes people write to us and we try to help as much as we can. Okay, so that is sometimes the problem, but for now, so far, it's going good.
Okay, happy to hear that. So thank you, Isabella, once again. Yes, and there was a PULSATE project, PULSATE opportunities, and now we are moving forward to another possibilities, the PhotonHUB Europe possibilities, which are delivered by the PhotonHUB Europe project. And now I would like to invite Ms. Nathalie Debaye, which is the vice coordinator of this huge project. So, Nathalie, the floor is yours.
Okay, welcome. Welcome to this presentation on the open calls of PhotonHUB Europe, the digital innovation platform or hub for photonics. I'm Nathalie Debaye. I'm the vice coordinator of this PhotonHUB Europe initiative. And this morning, the coordinator, Hugo Tienpont, has already introduced us to the very ambitious goals of Photonics Europe. Can you see my slides now?
Not yet.
Not yet. So let's try again. I hope this works now. Okay.
Okay.
Yes, sorry. So just to recapitulate, the PhotonHUB Europe is a pan-European initiative that brings together more than 500 experts in the photonics domain. And through one single gateway, you can access all these experts, top-notch from really photonics competence centers all over Europe. And more precisely, as a one-stop shop, we can offer to you as a company different support activities. One of them is the orienteering. There is also training and reskilling. And most important is the deep innovation support, where we offer innovation projects from TRL 3 up to 8, really to boost your innovation. We have additional also business and investment coaching, and we also guide you to regional funding. So, but to understand how photonics or how the Photonics Hub support program is working, and to fully grasp the support mechanisms on how you can benefit from it, I would like to start mentioning a few key principles. So we support European SMEs, like also Isabel has explained, but European, we understand the companies from the European member states and also the associated member states. And it is, of course, for photonics innovation, but really important, it is by their business needs. So we are not doing on a technology push, but we are looking to the specific applications of the company, and we investigate what will be the best technology is to further deploy their success in their business. We work on a gradual engagement of SMEs. So it's not that SMEs has to enter a full application, but we are having different steps where we guide, and at each step, the company will receive insights and knowledge from our best photonics experts. And with the different steps, the mutual engagement will also increase. So we start with a very low barrier, and gradually we guide the companies through the procedure, taking into account also very important aspects of confidentiality. It's not that they engage with the entire network, but they engaged with the experts that are of best interest for them. So we were working with continuous up call, so it's not a call with a fixed deadline, and we are evaluating the support request every 2 months. So it's a low risk. Since the first step is about orienteering and scouting, I will tell you more about that later on. Those steps are completely free for the companies, and there are no further obligations. But those steps will give you a more clear insight and a more better understanding in what such a project in photonics can mean for you. And also the project proposal will be written in concert with you, with a project leader out of the PhotonHUB consortium. Where local support is possible, we guide to local support. Where there is cross-border dimension in the innovation project, we also finance the innovation project through the PhotonHUB project. And we also facilitate the access to the pilot lines for the first-time users, and we can use, therefore, cascading funding from our projects. Also, we are looking for investors to further support companies who would like to innovate with photonics, and therefore we team up with several initiatives in Europe. So let's look to the first step, and that's what we call the orienteering, because we are really aware that different companies are at different levels on implementing photonics. So they have different maturity levels. And therefore, by listening first to the needs of the companies and where are they at which level in their process are, to look what is the best next step to boost that innovation for them. So are you really looking to implement for the first time photonics and you do not have the expertise in-house, or do you need assistance to build your photonics prototype, or do you have already a prototype and you look for upscaling, or you look for regional support, or for investors to finance your upscaling, or you look for to reskill your employees in the photonics? So all those different questions are within the orienteering to really define where we can help you the best. And for that orienteering support, you can contact us centrally, because we want to work as a one-stop shop, and we have a central orienteering officer. So there will be also a form on our website, but that will be only available from April onwards. For the time being, you can contact us through info@photonhub.eu. Or you can contact also our many local Photon hubs that are linked to PhotonHUB Europe, and they will orienteer you locally. And also in Lithuania, we have, of course, our partner, and also in Poland, we have our partner. So as a result of that orienteering, we will guide you if you the first step is more to the reskilling and training that your company is needing, or to find investment. But the most important part, where I would like also now to focus on, and where the most resources are available, is in the module on test before invest, or really the MRL in the market readiness level. And at the end of the scouting, the company will receive also a detailed scouting report. Within our project, we have a budget to do 500 of those scouting activities, to really invest in experts that are going into a dialogue with the company. And for the company, this is totally free and also without further obligations. And to receive such a scouting support, it is a simple form on our website, available from April, but in the meantime, you can also contact info@photonhub.eu. So after that scouting, it will be very clear at what stage your innovation project is. Is it about accelerating prototyping through innovation project, or is it an accelerating upscaling involving Europe pilot lines, facilities, or is it about manufacturing? And so from there, then we are coming into the project proposal, where those innovation projects will be elaborated. And for those specific activities, for those innovation projects, we have also quite a substantial budget available. And let's look a little bit more closely to the different levels. For the prototyping, we are really supporting SMEs. And we are providing innovation projects that are fully subsidized by the system up to the level of 30,000 euros to facilitate, for instance, feasibility studies. When the innovation projects go beyond that amount, 75% is still subsidized through this program, and we ask a 25% cash contribution of the SMEs. For the definition of the SMEs, I'm very happy that Isabel just mentioned that also in previous presentation. It's about 250 employees and a turnover of maximum 50 million euros. For the large-scale companies, we ask a contribution of 50,000 euro, 50% for the innovation project. That subsidy can go up to 100,000 euro for each of the innovation projects, and a company can also apply a second time for such an innovation project. At the upscaling, we mainly support the first users and early adopters. So whenever you are the first time that you have a specific type of photonics that you would like to upscale, then you can receive up to 50% subsidy for that project. Those projects can go up to 250,000 euros, of which 150,000 can be used for cascading funding. For the large-scale companies, there we can guide them what will be the best expert, the best technology, but to do the upscaling, they have to finance that themselves. There is also a possibility for a follow-up. What is important is that this funding will be used for the PhotonHUB partners to do your innovation project. So the company itself will not receive the funding, but will receive the technology support. So that's another way on putting it. The prototyping is at least 75% for SMEs subsidized. For the upscaling, it's 50%. And for the manufacturing, there we, of course, because that is already very close to the market, we will guide them. We will provide, and it's mainly by EPIC, they will guide you to the manufacturers of Europe, where you can find the components, the subsystems, and there you will be supported in that sense. Now, to repeat, we have for the prototyping a lot of photonics technologies in-house with PhotonHUB. Here they are displayed, but whenever you have a question related to photonics, you do not have to try to find out under which of those platforms it is situated. We can do that also for you. It's just to mention that we have a very broad spectrum of technology platforms. And for the upscaling, we are also linking up very closely with the pilot lines within Europe. They are really dedicated in scaling up in specific domains that photonics technology. Now, who can apply? So as I already mentioned, and very important, it is European companies and with a focus on SMEs. We do not exclude large-scale companies, but our main focus is SMEs. Companies that are looking for innovation support in photonics. At a pre-competitive level, we are supporting cross-border financially. And of course, the companies have to agree with our support procedure, and we have to check that there is no double funding for the same innovation activity. How to apply? Well, after the scouting activity, a project leader will be appointed. This project leader is an expert of PhotonHUB. They will write the project proposal in concert with the company. The project proposal is evaluated by a project evaluation board that exists out 12 experienced photonics experts. They meet every 2 months, and during the evaluation, you as a company and project leader can be invited to join in an online conferencing to answer additional questions. So we would like to really engage with you. In case of an upscaling project, there is also an assessment performed by an industry and investment committee to further support the take-up on the market. And after evaluation, we have a PhotonHUB funding board that then will allocate a budget for your project. And after approval, we sign an agreement, innovation agreement, and your project can kick off. About the project proposal that will be made together with project leader, that contains the details of your project with the scope, the target specification, the different tasks that we will do for you, the deliverables that will be achieved, the milestones, also a time schedule, when you can expect which step, and also about budget. Also important is that IP will be taken up. So we will discuss what is the background needed, what will be the foreground generated, and to whom it will be owned. An important aspect is also the business plans that go together, because we do not want only to leverage the company at TRL level, but also at MRL level. And we have on board on PhotonHUB some additional business coaches. Those business coaches are from our partners, Amires EBN and Schönenberg Harrison partners, and they are really looking forward in helping to boost that innovation for the partners. So that was the main part of our support. If after orienteering it's clear that now the next best step is the training, or that can also go together with the innovation project, we will have introductory trainings online. We will have an online catalog with an overview of the photonics trainings in Europe. So if you are offering also trainings to industry, you can contact us so that your training is also taken up in that catalog. We will have on site, hopefully not very soon, also at demo and experience center, so really to have hands-on. And we have a program to train the trainer experts. We will also have investment coaching. We will have a complete program also with funding box to help company to pitch for investors, to really meet investors. We have different events also to support that. So if you are interested there, we can really support you also there. So to conclude, we want, as one single stop shop, we would like to offer your trainings and support. But moreover, the test before invest, where we have these different steps on engaging with you are to your disposal. We would like to help you to find investors, and together we want to build a really pan-European innovation ecosystem and network. So I would like to thank you for your attention. I would like to welcome you to contact us. Soon our new website will be launched in April with a lot of information. But in the meantime, do not hesitate to contact me already at info@photonhub.eu. And I'm very happy to answer also some remaining questions.
Okay, thank you, Nathalie, for this very informative presentation. And this is amazing what you do, and this expertise and support for SMEs is just unlimited. This is something. And yes, we have a couple of questions, but first of all, I would like to ask my question. Yes, so are you familiar a little with the PULSATE project as well? So, if let's say I am the SME, so how do I choose between PULSATE and PhotonHUB? How to make the decision where to go, or take it both opportunities, or to select?
That's a very important question. And I have also very good and nice answers for you. Because the coordinator of PULSATE is also part of PhotonHUB. And that's one of the ambitions also of PhotonHUB, to really have that umbrella functionality to guide if an SME is, for instance, approaching us, that we guide and we see that there are more opportunities for them in PULSATE project, then we will guide them towards the PULSATE program, and vice versa. That is where I believe where we have to also be more strengthened towards in Europe, that we really link up with the different initiatives. And what's most important is the support for the companies. And whenever a company is coming to us and we see that there is more opportunity for them or more benefit for them in the PULSATE program, we will connect them with PULSATE. That is, in fact, the main idea. But more concrete is that how I see it in the PULSATE program, it is that you team up with the company that is providing the technology for the laser-based manufacturing, and a company who would like to implement and to bring that together. While we at PhotonHUB are more focused on a company, an SME, has a photonic challenge, and we look for the expertise to really make that possible. I hope that answers your question.
Great one-stop shop here. Okay, so now let's go to the questions. Yeah. So question number one. This is more probably related to the PULSATE, but yes, Kęstutis Naudžius is asking: can Lithuanian company apply for support services from FTMC? FTMC is Lithuanian experiment provider. Yeah. So
we can definitely help them to see where the best expertise in Europe is for them. And as if a result of our scouting would be that it is indeed locally, so in the same country, then this innovation project should be supported locally. If we see that an additional partner, for instance, from France, could also have an important role to play in that innovation for that Lithuanian company, then you have a consortium of 3 partners: a Lithuanian RTO, who is a competence center, the Lithuania company, and then a French partner. And then you have a cross-border dimension, and that will be supported by PhotonHUB. But if it is only locally, then there are within PhotonHUB no financial resources to support that innovation project.
Okay, thank you, Natalie. Next question, yes, from Gediminas. So, PhotonHUB project just started. When the project services will be fully functional for companies?
Yeah, I think I thank you for that question, because that I did not mention. So we only kicked off at the beginning of this year, and we are now setting up all the trainings, all the forms and the templates and so on. And from April onwards, we will have also our website where companies can enroll already. And we foresee to evaluate the first projects around the summer. So now it's in fact a time, if you want to engage, to already express your interest, then we can set up these scouting activities with you, and then a project can start after the summertime. But after that, it will be every 2 months that new projects can be granted.
Okay, thank you. The next questions from Christina. So, can consortium apply for the funding, or just only for the single companies?
Consortium can also apply. If there is really a win-win where consortium can together working towards an innovation project, that is also possible.
Yeah. Then, okay, the next question is, the project is very long, and the possibilities there are enormous. Yeah. So can SME apply several times with the different problems and ideas, and can these projects go in parallel?
Yeah. So we do not directly recommend parallel projects, since we believe also a focus is important, but several follow-up projects are possible. So regarding the finances, a company can apply a second time for an innovation project, and the budgets can go up each time up to 100,000 euros for prototyping, and on upscaling it is up to 250,000 euros. And there it's also possible to have a second application.
Another one question from Gediminas. Gediminas is active today. Okay, so if the company is not too much experienced with the photonics, which platform to apply in PhotonHUB? Yeah. I think Gediminas means this photonic technological platform.
Yeah, that's something what we really realize, that companies who would like to engage for the first time with photonics, it's not always very visible or very clear what will be the photonics technology that will best suited for their idea or their application. And that's why we're putting also such an emphasis on this first scouting activity, because it is with a photonics expert that the company will really look what is now the best technology. So it's not up to the company to already define and look for the best platform, No, we are doing that also with them. So they can rely on our photonics experts to be guided towards the best technology platform.
Yeah, okay, that's really great. One-stop shop, yes, for the companies. Yes. Yes, and another one question. Yes. So, what duration for SMEs projects will be foreseen?
So for innovation projects, because we are not doing that for the first time, we have already experience with ActFast program. Their average duration is about 6 months. So it's not that we will do an entire innovation from E to Z. So really having all the TRL levels at once, but that we really focus on jumping to the next TRL level and going with the company along. So it is about 6 months, of course. It's depending also on the technology that you require. For instance, photonics integrated circuits, they have a larger time to be evolved because you have the wafer runs and so on. So it can go up also to a year and 1.5 years. So we do not make a fixed timing on that, but on average it's about 6 months.
Okay, thank you. Let's move to another question from Mr. Justinas Katkus. Does the applicant have any power in choosing which partners of the PhotonHUB we could use? In example, he wants a specific research center to help on their project.
Yeah, of course. We do not have the holy grail within us. So we are open in discussion. And when we do that orienteering, that is also one of the questions that we are asking to the company. So have you already been in contact with PhotonHUB partners? Do you have already a preference? But we will not only go blindly follow the route or the pathways that companies are telling us. For us, it's also important to investigate that this is really the best solution for them. So we will take it into account, but if we see that there are better solutions or better partnership, then we will propose those to the company.
Okay, thank you, Natalie. So, dear guest, I encourage you, less chance to put your question for Natalie. Yes. Do you have any more questions?
Are you asking me for questions? Or?
Oh, no, I'm asking for the, thank you, Natalie. I'm asking for the, for our audience to put a question for you because it's an awesome opportunity, Yes, but okay, no more questions. So thank you, Natalie, one more time, and good luck with your project. Yeah.
Okay, thank you.
Okay, thank you. Bye-bye. Okay, so ladies and gentlemen, we are now moving to the next part of our Innovation and Photonics Technologies event. And now will be the pitch sessions for local SMEs. So today we have 4 pitchers, yes. And now I would like to invite the head of sales and business development of industrial robotic company, a man with a very beautiful name, Mr. Julius Vasilius. Please, Julius, you are welcome.
Thank you. Thank you for the opportunity to participate in this webinar. Yeah, as you mentioned, Julius is really beautiful name. So stage is mine. And I would like to introduce my company and our dilemmas and where our R&D unit is struggling, and we have some questions. So shortly about our company. So we are industrial robotic companies. We are developers of highly advanced industrial robotic solutions. So we turn those solutions into standard cells with focus to automate manual processes for manufacturers which are producing relatively small batches of production. And we are aiming in automotive, in general manufacturing industries, and some others. And currently we are facing we are working with 5 robotic cells, which one of these are RoboCut. It's autonomous plotter that prepares template for packaging boxes. It cuts out the perimeter, presses the bending lines, prints a product code onto each template, and the product is versatile enough to work with different materials, cutting angles, and radius. And all this is done by the one gripper, one head. Another one RoboCell is RoboMill. This is a drilling and milling robot that processes small product parts and is holding them in one of the specially designed grippers. Working stations, as you can see in the picture, is preset with tools, and they're positioned in a semicircle around the robots. And in those working stations, you can find router heads, drilling, sanding belts, and cutting saws, and whatever our customer needs. Other is RoboSpray. It's a spraying robot that lands. It moves from a human operator. The operator uses a standard spray gun to teach the robot how to spray a particular product. And this is easy to teach and quick to learn solution industrial robotic company has. And RoboSpray can start performing tasks autonomously from already second identical product. One of the latest our inventions is RoboSand. So it's a robot that sends semi-assembled parts or fully assembled products. It can be used to sand products before or in between the finishing processes. And this robotic cell also comes with integrated, easy to teach solution as previous RoboSpray robotic cell. And we have one more cell. It's a RoboPack. So it's a duo of packaging robots working in parallel with moving conveyors. One of the robots comes with a special design gripper, and it takes product from a pallet and places on positioning table, while other robot puts the product into moving box on conveyor. So as you can see, that photonic technologies in industrial automation, it's a daily basis for us. It's the sensors, it's lighting, it's also safety grids, and so on and so on. And as we continue our R&D process, we strive for perfection for our customers and constantly searching for solutions to achieve, of course, better performances for speed accuracy, for durability and broader tool capabilities. And we can proceed this list more and more, but let's say dilemmas that we currently face is talking about RoboCut and special this multifunctional head and gripper with integrated tooling is dedicated to prepare packaging box. So the gripper tooling consists of mechanical knives for cutting, its roller, which presses bending lines and also on the cardboard, and also there is ink printer to code each template. So this solution is already working in our premises. It's not a problem working, but we have some limitations with mechanical parts, so with paper knife and also ink printer, which makes our process a little bit slower. It limits our cutting flexibility and limits materiality. So could laser technology be used for cutting and marking the required templates? This is our question and the pitch, one of the pitches we are looking for. And also, would this allow us to increase the cutting speed we have already now? And can we gain, of course, cutting flexibility with the shapes, with radiuses, cutouts for handing to take all the boxes, for movers, and so on? So this is our question about one of our solutions. our dilemma is with our easy to teach solution. It's combination of our hardware and software, and it makes it easy for every person to program an industrial robot. It tracks and records human movements and quickly can convert these movements to robotic language. The robot follows the same path as a tool in a human hand and also at the same speed and acceleration. And even the tool angle is kept at the same as the sprayer done before. So the solution is based on cameras and infrared diodes in 3D environment, which makes a precision measurements of motion sequence in space. But question that we are using optical system, that we're using cameras and lenses, so which cannot guarantee enough accuracy, let's say in a welding industry where accuracy is a must. So the question is, would a laser tracking system be a better solution in such a case? And would we achieve a faster live response, get better accuracy, and be able to work with, let's say, bigger objects in quite large environments? Because if at the moment, if you want to get a bigger image, bigger picture, we need more cameras and so on and so on. So this is also our question in this pitch. And of course, third and last but not the least, our dilemma is that we are using 3D Azure Connect cameras to perform some tasks. It's product recognition, it's product positioning, it's product packaging, and so on and so on. So far we have tested few other solutions like industrial 3D cameras and but not found anything more promising yet that, let's say, this 3D Azure Connect camera. So maybe lasers or other solutions might challenge these 3D cameras for better product recognition, positioning, and packaging, as you can see in our picture, in my slideshow. So short introduction about our work. We have not a lot of time, so if there is any ideas we can cooperate with and add more value to our customers, you can contact me, and I'm open for discussion with possible partners.
Yeah, so thank you, Julius, yes, for this nice presentation. And I don't know, our listeners and solution providers, have you saw Julius' email? It is julius@industrialrobotics.com.
.lt.
Yes, so I'm pretty sure, Julius, that you will get a lot of proposals.
I hope so.
Community, yes. And we have one question, yes, regarding to your presentation. So, yes, Gediminas asks, what accuracy is needed for teaching, let's say, 1 millimeter per meter?
It should be less than 1 millimeter. If we are talking about welding industry, it should be really, really accurate. So we need better accuracy than 1 millimeter, because with now existing system, with optical system, we can gain this. We can get this 1 millimeter accuracy, but for the welding industry, it might not fit. So we are looking for better solutions. So it might be laser tracking or something like this. So this is really important for us.
Okay, thank you, Julius. And another one question from me, does your company more focused on the local industry and provide solution to local industry, or more to the international customers?
Because let's say that, because we are looking for standard solution, we are looking not only in Lithuania, because we have few companies in Lithuania which are making, let's say, wood, performing with wood, but the same problem as this company has also abroad companies in Poland, in Germany, in Finland. So as a standard robotic cell, we can sell the cell also to other countries, other companies, not only Lithuania. So we are trying at the moment Europe-wide, and I think in the close time we will be able to go abroad.
And okay, and have you any experience already in this I don't know, open calls? Yes, and what do you think about this open calls? Will you go on it?
Yeah, I heard about all these open calls today. It's a really nice webinar we had. So I'm really interested to listen all these possibilities for small companies as we. And I can say that all these cells we created is in using European, of course, funds. We used European funds to create, and now we are commercializing these products. These projects are already launched in some companies, and now we are looking for partners, and we are trying to go globally.
Okay, so thank you, Julius, for sharing your problems. Yes, and PhotonHUB and PULSATE is the right place, to share with.
Yeah. Thank you for invitation.
Okay, bye. Okay, ladies and gentlemen, so when you need outstanding experience, in the extra hard material, laser microfabrication, so who you gonna call? Yes, Egidius Vanagas. So please, Egidius, from CEO of Evana Technologies, make your pitch speak.
Switch your microphone on.
Egidius, we see you, but do not hear you.
Okay, now you hear me?
Oh, yes.
Okay.
Now we hear you.
Okay, so do you see my presentation or not?
Yes, we see. We can continue.
Which one? This one? Okay. So, as you know, I am Egidius Vanagas from Evana Technology, and I will go through our laser technology solutions in the processing of different semiconductor dielectric materials for different industry and some applications. So first of all, I will show that we also provide some technologies and also dedicated tools for the implementation of these technologies. We have some solutions for ultra-fast laser micromachining solutions as icicle and thermolaser cleaving technologies for hard and brittle materials. Also some processing of more soft materials, amorphous, plastic, flexible, and biomaterials. Also, we are working on a research project on laser pinning, laser waveguiding in silicon, and some other projects. Our head solutions is freezer series of optical engines for industrial scribing stations. So we're working on few materials. We already make some good achievements in silicon scribing, sapphire scribing, quartz scribing, glass, lithium niobate, lithium tantalate. Here is icicle technology in use, and also gallium arsenide and germanium. We plan to do this in the future if we have some good situation for the some really some output of the air from our lab. Also, silicon carbide, we cleaving with thermolaser cleaving technology, and in the future maybe we will try gallium nitride or diamond. We have 3 patent families, and for 2 first we have already issued for every family for 6 patents worldwide, and 1 patent on the optical design of optical path. So here you can see silicon scribing result on the left side after scribing processing, and on the right side is on the after breaking processing. You can see the edge of the silicon wafer after scribing, which is 200 micrometers thick. Here you can see some strips of silicon which was broken by manually, and also we can make some round shape of scribing of the silicon and breaking into the round circles. Next is sapphire scribing for LED dicing. Also we got quite good results, and you can see some appearance of the silicon sapphire scribing parts. Here you can see a lithium niobate wafer, which is quite material is quite fragile and brittle, and we get this scribing quite well, and really with quite good result. Same situation with lithium tantalate. These 2 materials is quite similar, and conditions for the scribing of these materials also very close. So also results is quite good. Here you can see very thin quartz scribing. Thickness of quartz plate was 50 micrometers, and we got quite good result with minimum chipping and really good breaking. Next is thermolaser cleaving technology, which we apply for silicon carbide, which usually is dedicated this electronics for radio frequency and high power devices. And you can see top view after scribing and breaking, and edge view of the breaking line. Here you can see silicon carbide, which is coated by gold, where it's some final stage of electronic devices manufacturing before scribing and dicing. So we make the scribing in one pass for gold removing, and at the same time also material scribing. And here you can see edge view and some comparison on the right side with our competitors from 2 companies outside Lithuania. Here we can really estimate what price would be for 1 million wafers per year to make processing with our icicle technology, and you can see we need for this amount 2 stations, and also almost 1 million investment. And for diamond dicing or some really processing with ablation laser processing, it necessary 5 stations and plus 3 million for maintenance. Even better situation for silicon scribing, where you can need only 2 stations for worth 1 million euro, and 21 station worth 4 million euro and 15 million for diamond soil maintenance. So we can compare this. So this is really short and brief overview of our activities, and if really somebody find that is interesting, we can collaborate, cooperate, and have a good business together. So, if you have questions, please ask.
Okay, thank you, Egidius, for your presentation. Yes, and we have a question here. So, what kind of end users are you looking for? And from my side, how do you imagine what is your ideal end user of the dreams?
End user of the dreams will be some kind of integrator mainly, because really integrators have quite good competencies in the really market, also customers, and also what kind of achievements or what kind of the high technology he need for some certain job to do. So I think that this is ideal customer, but also possible some end user. But this is really how to say. In this case, we can try to do these stations within Lithuania with our really friends from our ecosystem.
Okay, that's great. But what would be the sectors or profiles of the companies? Let's say, could you give us some examples of applications?
Mainly, our process is dedicated for microelectronics sector. It means that this is tools manufacturing companies for microelectronics, semiconductor microelectronics, or some kind of material processing. This is really that direction should be. We got good result with silicon scribing, and we are, how to say, we're willing to get some customers for this process also.
Egidius, and have you ever participated in this like open calls ever before?
Not yet. Open calls, it means that what? Open calls?
Yes, that means that grant for innovation, yes, with a partner from another country,
No, we don't participate.
Yeah, so it's pretty good opportunities for you and for your company, yes, to develop some innovations. Yeah, so I see, yes, no more questions there is. So thank you, Egidius, once again for your presentation, and
you're welcome.
Good luck.
Thank you.
Okay, bye-bye. Yes, so ladies and gentlemen, now we are going to our third pitch from the very special company, the company who brings us the light. And yes, this is Balt LED and CEO Mindaugas Jasiulevičius. So Mindaugai, the floor is yours.
Thank you very much for inviting me here. And I would like to present for you our company shortly and make a short introduction about the challenges we have, let's say. So I hope everything with the screen is fine right now. Do you see my presentation?
Yes.
Okay. So as Julius told, we are a lighting company, and our main business where we are is at product development, product manufacturing, and also these lighting.
Oh, Mindaugas, you muted yourself.
Okay, how is the bar? No?
The bar is fine, yeah.
Okay, So sorry about that. So we are in the lighting business, as I told you already, for 16 past years. We are an SME company who makes the R&D by ourselves. So we design the luminaires or any other lighting things. We prototype them, we produce them by ourselves, and we even design for the customers the light and then supply them with the full solution. So our company have one second, why it's okay. So our company has 3 different business areas. One is the signage lighting for the street signs, for indoor signs. Another one is street furniture lighting, such as the bus stations for the cities and for the how to say, banners for all the advertisement on the roads. Another one is general lighting. So in these sectors, we do cover a lot of applications, and for that we have a lot of products, let's say. And for the signage applications, we do have already 13 different product series, which mostly all of them has different optics for the different optical results, use different LEDs, different powers, different designs of thermal things, and different, how to say, connection methods for the end user to choose. And these cover for the applications such as backlighting, edge lighting, ceiling lighting for the end users, and as I told before, like street furniture lighting. Our big segment is the professional LED lighting for the general lighting. So it's covered in our company production and warehouse facilities lighting, supermarkets, offices, professional outdoor lighting and lighting management to give full solution for the customers. And you see down here product series which is developed by us, adopted the most well-known brands LEDs, developed some of the optics by us, some of them is from the market. And we are like, as you see, a product and an application integrator for the technologies that are ready for the market, let's say. And as this past year, we all know that we have a pandemic, and we have one more new area where we look at it, and it's light and disinfection area, we call it like this. And this pandemic, we think that it's not going anywhere from us and from our lives even more than 5 years or 10 years. So we have to keep working with that, and we have to be safe also with this type of pandemics in the future. So there is an application, as we call it, light and disinfection, which could be used in every, how to say, area where we do need a light. So it's an idea, if you have a lighting, you should have a disinfection also system together built with the lighting. And then you can have like a lot of different areas when you have a disinfection, the light which could make a disinfection. And you can use anywhere from the buses, airplanes, to the schools, airports, and even for the hand disinfection. And one of the biggest goals is to make a contactless disinfection without asking for people to go out from the facilities or doing this at the night, let's say. Because let's say in the airport, you cannot find the time when you can make the disinfection, and if you turn the light, and some standard light engine sources which there are in the market right now, so you have to ask the people go out. And the challenge for us is actually that we cannot find really commercially usable and available light engine, which is really could be used for contactless disinfection, will not, make any disease for people, and can be adopted in almost every luminaire. Since the luminaires is everywhere all around us, so it would be a good thing to put the light that could make a contactless disinfection for the facilities, or even the people and so on. So that's the challenge, and that's the the area which could be photonics can help for the world to fight and be safe in the future. So thanks for time, and I hope that we could find some partners and try to maybe implement this idea.
Okay, so thank you, Mindaugas, for sharing, this your innovative ideas. And yes, because you do not find, the right this laser sources, because it's probably a little challenging. Yes.
Yes, we already know that. We check the market since we are working with a lot of light sources around here. We know that this is a challenge, but sometimes hard work can pay out.
And so we have one question for you from the technologies provider. So Evana Technologies asks, it should be enough 252 nanometers. Is it? Is it enough 252 nanometers?
It's actually, for the disinfection is enough, and it's really good wavelength for the disinfection. But there is one problem, another additional challenge that is also makes it is harmful for people and harmful for people's skin usually and eyes. So we cannot use this in the area where we have people. So today we know that there is a lot of disinfection products, but almost there is nothing that could make a disinfection together with a human, let's say, in the facility. Lamps or other light sources, which is really very hard to make a final product with that. So LED would be a good solution, but we need to find that who develops that, or maybe could develop that.
Okay. And, another one question from Christina. Are there similar solutions?
Yeah, as I mentioned previously, there is already many equipment for the disinfection in the air or directly for the surfaces, but all of those disinfection tools is really not good for health of people, for the skin and for the eye. So this is the biggest challenge for those facilities who has all around working 24/7 like airports. So you cannot find the time where there is no people and then make the disinfection. So you have to have a light which is really not harmful for people. Then you can make all the other lights become a disinfection lights together, and then you can cover a lot of area, and then you can actually try to fight with the pandemic and even reduce the risks of the pandemic, let's say.
Okay, so there is no more questions. So thank you, Mindaugas, for sharing, and it is really challenging, this innovative idea. But as I said before, the PhotonHUB and PULSATE is the best place where you can share, this your ideas, and we will help to implement this.
Okay, thank you. Thank you.
Yes. Okay, so bye.
Bye.
Okay, so ladies and gentlemen, we are moving forward to our last pitch presentation. Yes, and from the company, the solution providers, the world's smallest turnkey lasers. Yes, and I would like to invite Mr. Evaldas Pabrėža, CEO of Integrated Optics. So Evaldas, the floor is yours.
Hello, everybody. Nice talking here at this event, and I hope that some of our ideas will catch your attention. And we would like to build a consortium around few or one of the ideas that we are planning to implement. And we would like to have a European level consortium. So quickly jumping into it, we are a company, a small and medium-sized enterprise having 40 employees, and we produce lasers. We were established in 2012, and since 2014 we started producing matchbox lasers. So these are high-performance lasers. As you can see it in my hands, it's quite compact. And since 2014, nobody has catched up with the size of a lasers. If you compare, apples to apples, like the same specifications of the lasers, our products are still the most SWaP compatible. SWaP is size, weight, and power, which is often desired by various industries, from aerospace to automotive or to portable lab devices and stuff. Actually, the field of interest and the applications is really broad. And here in the darker circles, I have wrote the industries which we serve or somehow would like to serve. And on the lighter circles, you can see physical principles where lasers can be used, and these principles enable these applications. So automotive might use LiDAR for environment scanning, and also photon entanglement for secure communication between the cars and between the base or coordination spots and the cars. In communications, you can also use entangled photons for safe data transfer. And also you can use power over fiber and sensors together with power over fiber, which both of these applications I will elaborate a little bit more in a few showcases later on. In recycling, you can use laser-induced breakdown spectroscopy or Raman scattering or even fluorescence. And in pharma, you can use Raman scattering, fluorescence, and relay scattering in analysis of particles, and analysis of concentrations of particles, and for example, motion of particles on elevated temperatures. And similar applications span over biotech and medical diagnostic markets. So what we do, our core activities and competencies are in producing laser sources, also developing custom laser sources, also adding some optical layouts to the laser sources. So for example, we have really successful business cases where we were asked to sell a laser, but later on we ended up with integrating few additional optical components next to the laser in order to miniaturize and solve the problems for our customers. In some cases, our customers didn't had, or they had mechanical assemblies, mechanical and optical assemblies, which were really troublesome to align and maintain stable over time. And we used our robotic assembly techniques to bond these optical components to a substrate and have them stable over time. So as I already said a few words about it, we are also developing robotics for assembly of optics, but we don't commercialize it. So it's just among our technical capabilities to use robotics and develop robotics for optical assemblies. So this is, as I showed in my hand, is a matchbox laser, and we have more than 200 product configurations in the same footprint. The series was awarded, not awarded, but nominated for Prism Awards, which is the very prestigious award. And we have some products which are like, simplified versions of the matchbox. It's just the optical part separated in a separate housing without electronics. So the matchbox has all the electronics inside, and these guys don't have electronics. And we also produce some substrates for very low concentration detection in chemicals or in biological samples. So going to the showcases, so one of the showcases is the quantum cryptography application, where the typical layout says that there is Alice and Bob and they have communication between them. And in the post-quantum era, this communication will be compromised if Alice and Bob will use the mathematical cryptography solutions, this will be easily compromised and it will be not safe to do communication anymore. And there, some physics methods come into help how to secure this data. And one of them is quantum cryptography. So basically, one of the potential applications is to have a satellite, like a small satellite, which is sending the quantum keys both to Alice and Bob, or doing the whole communication through the satellite. And so there in the satellite, you must have something small and compact, which can, carry out the entangled photons. And as I said, size, weight, and power is the main characteristic of a laser source, which must be there. Another showcase is a remote sensing platform, which is resistant to electromagnetic fields, very strong electromagnetic fields. So imagine you have a sensor box where you would like to put a microphone, a vibration sensor, temperature humidity sensor, or basically any other low power device. Also, you want to have communication to the module and back from the module. Also, perhaps some electrical signals should be delivered to other devices near the module. And the whole module should be powered over a fiber. So imagine this small box with lots of sensors and communication capabilities is connected with just a single fiber, and it delivers communication to this fiber. It gets communication from this fiber, and also it gets optical power from this fiber. And on the other hand, on the other side, you have another module which has a high power laser for power delivery, a forward communication laser, and a photodetector for receiving communication. So at the moment, we have something very close to this on this side. And technically, we can implement something very similar on the other side. So there would be basically two matchboxes, or a matchbox and a similar size module on the other hand, which communicate between and are powered through a fiber. So and such a solution would be really immune to electromagnetic fields, both in case, let's say, an electric power grid station, or in case electromagnetic bomb attack, or anything else. Also, the fiber will be hardly detectable. It does not emit any electromagnetic field around it. So all the light goes inside the fiber and is very difficult to detect. So here we need technical problems to further go on this development. And we would like to find partners who are in the power grid field, or in the military field, or in some other maybe space applications where one of those showcases could have advantages. So please tell us your problems, and you're welcome to contact me and these contacts, and we'll be happy to collaborate.
Okay, thank you, Evaldas. I don't know if you see well these letters. So the Evaldas email is e@integratedoptics.com. Yeah, so thank you, yes, Evaldas, for sharing your ideas. And I do not see questions, yes, from the audience. So I will ask, just a question. I observed that one of your products called Samogitian. So it's related, to the Lithuanian geographical, very important region, Žemaitija. So what is special characteristics of that series of product?
Yeah, well, me and my business partner, we are both Samogitians. So we think that Samogitians are small and strong. So this is why we call the product that way.
Okay, that's really.
This very small laser, it's actually the size of my thumb finger. It has up to about 1 watt of optical power, and it is narrow spectrum and it's dedicated for Raman spectroscopy.
Okay, beautiful. And Evaldis, yes, we have a question unexpectedly from Gediminas. Yes, so Gediminas asks, what kind of laser do you propose for quantum
cryptography?
Yes. Thank you.
Yeah, we are selling our narrow spectrum lasers for quantum cryptography. Those lasers are CW lasers, and our customers, they generate photon pairs by pumping a PPLN crystal, periodically pulled crystal, with our laser, and then there's another optical layout to manipulate polarizations and sending the photons to the recipient and the sender. So yeah, we use very narrow spectrum CW lasers, basically at 785 nanometers for the fiber telecom and 405 nanometers for the free space communication from satellite.
Okay, thank you, Evaldas. As I see, no more questions here. So yes, once again, thank you for sharing. We will write down, your intentions to look for grid and defense companies. Yes, and we will exploit these solutions. Yes.
Okay, thank you.
So, thank you. Bye.
Bye.
Yes, so, ladies and gentlemen, the pitch session part is over. This was the last presentation, and now we are moving forward to the best practices part. So today we have 3 guests, 3 speakers, companies who already participated, in these open calls, companies who already used these pilot lines and experimental opportunities, and they today will share their experience, their impressions about this, about participating in these open calls. And I believe, that everybody of you will find yourself in this experience, and this will inspire you to participate. So our first speaker in this session is Miss Marta Garcia Cosio, and she is an aerospace director at CITD company. So Marta, you're welcome. The floor is yours.
Thank you, Julius, for your welcome. And thank you, for inviting me to share our, experience with this AMABLE project. And I will try to share, okay? And I have 7 minutes to go through it, and I will try to give you a good overview of how we apply it. Then, in this case, it was an AMABLE project, and it was a feasibility study, because we had 2 different levels of it, and this was just the first step. Then what we select is to use the application of a laser melting deposition by wire on an aircraft engine mount. In fact, it was an electric aircraft engine mount. Then it was done by CITD, and the tutor was Oliver Abram from Subsea. Then CITD is a company that is an engineering company really focused on the aeronautical and space sector for the last 20 years. And then we were the last 4 or 5 years really focused on the application of other additive manufacturing technologies as SLM for the space sector. We already have flying parts on the space sector, and then it was the time to try with another technology on additive and another field of application. That's why we select them to go to this engine mode. Here we can see in the picture the typical engine mode in steel with the electric engine on it. And this was a project that we had, and it was very difficult, the lead time for for the different materials, and as well the mass is always an issue on this kind of aircraft. And we just proposed it for this experiment. Then we just did fast planning on the topic. It was just only 4 months where we had to review the requirements of the technology and the product, and then to just redesign all this structure in line with this technology. And not only that, we don't need to, it's important not to forget the business case associated to all these new technologies. Then the experiment ended up with some sample manufacturing and testing. It is very important to note that we took the advantage of different services that the AMABL project was offering. In our case, this is the full services that is proposed. These services allows you to stay, to keep in contact with experts on different areas where you can get some support. Then we identify different gaps, as for example, technology capabilities and as well the industrialization process, just to go through the process cost and limitation, and even the material selection. And in this case, Subsea and AMEN were the ones supporting us on the expert part. It is also important to see that the business plan is part of this kind of projects, and it helps us a lot to new technologies, to see how to apply this to different sectors, but as well, we wanted to go through prototyping to serial production, and that things about different topics as certification, airworthiness, and so on. And as well, we are thinking on transferring these outsourcing manufacturing capabilities to insourcing, and then we need to have a clear business case. Then we went to this redesign of the parts with some topological optimization and to define as a representative coupon. Okay, that is very important to test this technology. In this case, the coupon, the real part is like 700 millimeters in both directions, more or less, and this coupon is 200 height and 30 millimeters on the diameters. It was done on steel. Then we manufacture it with this company, Meltio Technology, and we did it. This technology is very fast and cheap, and that was one of the key points on this experiment. We did it with different wires diameter, 1.2 and 0.4. Okay, you can see the different quality and so. And then we went for the testing of it. In this case, the testing for us was very important to know the distortions. Then we scan the part and we see the different, distortions during the process, and as well to see how can we post-process this. We try to post-process the interfaces, then the inside and as well the outside. Okay. And here we can see the final coupon. We only have machined the outside on half of it just to check the difference, okay, between them. And it was important to measure as well the roughness. Then, this experiment for us it just finished now, and it was in fact very good because it allowed us to increase the knowledge of going into bigger structures with additive manufacturing. And I will highlight on this kind of project that, the flexibility of all the organization, the tutor and so on helping us to reach the best technology. We were starting to think on one technology, and we are not thinking on laser melting deposition by wire technologies and different materials. As well, the knowledge that the AMABL consortium can give you about materials, process, and advice is a nice point. And they help you to keep the focus on it. The tutor always keeps you on the right track to arrive to the right conclusions. Then, yeah, for us, it has been a very, very nice, to do this feasibility study, and the results, were quite good. Then I would really recommend to any SME, to go through one of these, because you increase a lot your knowledge and you take advantage of the full community of experts. And yeah, thank you.
Okay, thank you, Marta, for your presentation and for the inspirational words for the future innovators. Yes, and we have a question for you. So, are you still using AM solution, AM additive manufacturing solution? Yeah.
Yes, for sure.
Mm-hmm. Yeah. Okay, so, no more questions. Yes, so thank you.
Thank you,
Marta, for joining us, and
great.
Good luck innovating.
Yeah, thank you.
Okay, thank you. Bye-bye.
Bye.
Yes, okay, so ladies and gentlemen, now we are going to the next presentation from another company which used also competences and expertise from the project last year. And I would like to invite Business Development Manager at New Infrared Technologies, Mr. Rodrigo Linares Herrero. So, Rodrigo, you are welcome. The floor and the screen is yours.
Hello. Thank you very much for the presentation, and also for giving me the chance to give you some overview of our participation in last year. So the title of my presentation today is Real-Time Monitoring and Control of Laser-Based Processes Using Uncooled High-Speed Mid-IR cameras, but it summarizes the participation in last year. Just a quick introduction to New Infrared Technology. So we are a company that is located in Madrid, and we are focused to develop and commercialize industrial solutions for real-time process monitoring and smart control of laser-based industrial processes. We have the technology to produce infrared cameras. We can build infrared sensors that are manufactured with a unique technology, which is sensitive in the mid-IR range, 1 to 5 microns. They have high-speed capabilities, and they can operate at room temperature without the need of cooling. So most of our solutions are based in our cameras, the cameras that we manufacture. So a general overview of last year. This last year was a huge project, a huge consortium that happened under the 7th framework program a few years ago, which acronym was Laser Equipment Assessment for High Impact Innovation in the Manufacturing European Industry. The aim of last year was to develop a framework to assess innovative laser equipment in order to bring it into the industry, into a real application. So basically it consisted of multiple experiments, assessment experiments that were testing different laser equipment to target strategic manufacturing areas for Europe. The budget of this program was 15 million euros. It was a very long project of 63 months. And a lot of companies all over Europe participated within the multiple experiments. I've put there, there were 6 research institutes to mention: the Fraunhofer Institute in Germany, which was the coordinator, IMEN, which was our main partner for the experiment in which we participated, but also PhotonHUB in France, Cartif in Spain, Laser Centrum Hannover in Germany, and the TWI in the UK. In between the 72 European SMEs of 14 countries that participated in the project, it was one of them was NIT. And the way that we participated, it was in what was called the laser equipment assessment. This was an approach to bring together the demands of the industry to increase the efficiency in manufacturing, mainly applied application of laser, the potential of the SMEs to deliver innovative equipment, and the background of European research entities that all together would bring a support to success in such a challenge in bringing the application of the laser into the real industry. So they developed what they call the assessment circle, which was a sequence of activities in which it was conducted by the three partners. One of the partners was the research partner. In our case, this was IMEN. Then there was the technology supplier, which was NIT, and then we had the end user. In our case, it was Central Research Fiat. Our experiment was called LASPRO, and the main goal was to assess high-speed infrared, to assess the application of the high-speed infrared monitoring to the laser welding process in order to monitor the process, the quality of the process, and control the process. The main goals of this program was to develop and implement a technique for inline quality control of laser welding processes with a future aim to perform a closed-loop control of the process, reduce the quality assessment costs, and reduce the defects in the process at least by 50%. This slide shows a little bit of a quick summary of the experimental phase done in LASER, in our LASER experiment. In this case, you can see that we have three main components here. We have the camera, which is monitoring the welding process in real time. The camera is installed in the laser optics, which is bringing the laser into the process area, and then we have the welding process. In this case, what we did is put the camera coaxially in the laser optics and monitor directly the weld pool in real time. And with this data, we intend to correlate it with some defects during the process in order to assess the quality of the process. The results that we obtained showed a clear correlation between the dynamics of the melt pool and the arising of welding defects. As we are monitoring at 1,000 frames per second, we are capable to see variations in the melt pool, like in the example that you can see in the image. So we have a weld, two sides of a weld, invisible. You can see in the back side we have an area where there is no weld, and this can clearly be seen in the dynamics of the melt pool. If we observe one of the dimensions of the melt pool, we can see that in this area of the process where there is a lack of penetration, you can clearly see that there is a deformation in the melt pool. Ultimately, we used LASER as a first real technical assessment of the laser welding process quality using our cameras. This was the basis to develop a solution that was called i3 Laswell, that was developed together by NIT and IMEN. And we have a real implementation case, which is the deployment of this solution in a tier 1 company for quality assurance of a remote welding process on the fly, in which we are doing a quality control of around 10,000 welds per production shift. So as the previous speaker was saying, we recommend to participate in this kind of experiments because you can clearly prove some concept. You can make a proof of concept, test it with the support of the research partner, but having in mind a final application, which is the case, in our case, was provided by CRF. But afterwards, you can use all this information, also all this knowledge, all this know-how in order to develop a final solution that you can bring into the commercial market. And with this, I finish my presentation, which I hope was interesting for you. Thank you.
Okay, thank you very much, Rodrigo, for sharing with us, And we have one question for you, yes, from the participants. So, could your solution will be applied in laser microfabrications with ultra-short pulse lasers? How do you think?
Mm-hmm. in the case of the solution that we developed under the LASHER project, this was oriented through high power laser welding processes, continuous laser welding processes. But in that case, we use artificial intelligence. We use a deep learning technique in order to identify the defects in real time. We have applied similar concept to short-test welding, where we don't use images, but we use other kind of sensors in order to be able to provide a real-time assessment of the process. So I would say the knowledge that we have gained with i3 Laswell could be applied, can be applied for that application in particular. Yes.
Okay, thank you. So 2 more questions from my side. So, about this open LASHER project and open calls. So how does the information about LASHER, came to you? How you are the SME, how you knew about these opportunities, LASHER?
All the traction from NIT to participate in LASHER was coming mainly from IMEN. As you know, IMEN is also a center that is located in Spain, and they, from the very beginning, they could see a potential of our technology to be applied for quality assessment, or at least for monitoring laser processes. And when LASHER was published or announced, they thought that maybe it was a good chance to test the real performance of our technology for this application in particular. So we were invited by IMEN in order to cooperate or to join LASHER.
Okay, that's nice. And the second, my question is, about the forthcoming open calls, this really grand European consortium, PhotonHUB Europe and PULSATE is planning and already launched some open calls. So you as an SME, like a user of, like a client, potential client of this project, what would be your, advice, how to improve, this open call, this administration and process, let's say, to make most attractive for the SMEs? Have you got any experience and advice?
Yeah, I think in LASHER, I think the focus has changed since a few years ago from the case of LASHER, which was a very big consortium with too many participants. It has changed into open calls that are involving less actors. We know, we were aware also of Amable, as the previous speaker has announced. And I think these are calls which are less ambitious. They are shorter in time, and I think this is more interesting for the SMEs, because in a very short period of time, you can make a proof of concept of your application or your process, and you can obtain a shorter time to market in your development. There is now PULSATE, which is another open call that is open, related with additive manufacturing, and there are others related with other technologies which are quite attractive for SMEs like NIT.
Okay, so thank you, Rodrigo, for sharing and joining our event this afternoon. So
my pleasure.
Good luck. Yeah.
Thank you.
So, ladies and gentlemen, now we are approaching to our last presentation of this session, and I would like to invite Mr. Frank Smith, CTO at Pilot Photonics. So, Mr. Frank, the floor is yours.
Thank you very much. So today I'm going to talk a little bit about our experience with the ACT-FAST program, and the title of the talk is Developing a Super Channel Transmitter PIC through the ACT-FAST program. My name is Frank Smith, and I'm the founder and CTO of Pilot Photonics. So Pilot Photonics is an Irish university spin-out company. We use comb laser technology that we've licensed from the university that we spun out of, and we use it to develop photonic solutions in multiple application areas, including data transmission, sensing, and metrology. We've 13 employees, and we're expecting to grow quite considerably this year based on a new investment round that we're working to close at the moment. We offer a full stack photonics offering, so everything from EPI design all the way through PIC design, layout, RF and packaging design, and into controller electronics and software management. And we've been recipient of one of the quite prestigious EU SME Instrument Phase 2 awards, and also 2 times winners of the European Photonics Venture Forum. So we've been globally recognized as a PIC innovator, and the ActFast project has really allowed us to continue and accelerate that aspect of the business. In terms of the market opportunity that we're tackling with our ActFast innovation, global internet traffic has grown more than 50 million times over the past 30 years. This relentless demand for bandwidth has led to a capacity crunch in the internet. And we have a key technology, our patented comb laser technology, which packs more data at lower cost into existing fiber networks. And this allows our customers to really maximize the use of their existing infrastructure and investments that they've made to date, while offering new solutions and capacity to their customers. So it's a large market opportunity. The global market for optical transceivers will reach around 11 billion next year, and we play into a key part of that in the optical transport market initially. So ActFast, this is from their website. It's a unique one-stop shop, open access, full supply chain for supporting your photonics innovation. And really, from Pilot's perspective, we are a photonic integration company. We have that expertise in-house. However, what ActFast has allowed us to do is to transfer our existing PIC technology and platform to a new fab, which offers the ability to enhance our offering essentially through additional functionality and performance, particularly around high-end coherent communication modulators. It's also allowed us to kind of enhance our own internal competencies in this space and to deepen our engagement with the European photonics ecosystem. So we're in Ireland, and there is a good photonics ecosystem there, but really to link into the rest of Europe, the ActFast has been really great from that perspective. And then the kind of key output that we want to achieve here is to build a demonstrator of our comb-based super channel transponder to attract commercial interest from tier 1 customers in this space. That's the goal here. So briefly, just to give people an idea what the application process is. So this is our second ActFast project actually, and we're still having benefits in the company from our first one, which was a few years ago. But it's a very simple process. You submit a short summary, a couple of paragraphs up to less than a page of your innovation idea to the ActFast team, and then scouts are assigned from within the consortium. You complete a questionnaire and provide more detail both on the business plan, so the kind of market opportunity, but also then on the innovation itself. Then with the scout, you prepare and submit the formal proposal, and you develop that kind of hand in hand with them. Next step is if it's accepted and deemed suitable, you're asked to attend a face-to-face interview alongside the scout, with the technical review committee. And if that's successful, then the scout becomes your project leader basically, and funding is awarded. And this can be up to 80% of the total cost of the project. So it's very beneficial and allows you to gather a kind of a real high expertise project team from multiple institutions and companies around Europe. So in our case, we have the Technical University of Eindhoven, Heinrich Hertz, Fraunhofer HHI in Germany, and then the Tyndall National Institute in Cork, along with Bright Photonics and ourselves. So a really strong consortium. So what we've done is basically develop a highly advanced photonic integrated circuit. It's in terms of what's been developed through this fab to date, and they say it's one of the more complex and ambitious PICs that have been developed on their multi-project wafer platform. So the block diagram is shown there. Essentially, what we do is with our cone source, we create 4 coherent wavelengths, and we then pass them through 4 high performance IQ modulators to achieve what's called a super channel. And a super channel is basically a way to continue to increase the capacity of optical networks and to pack more and more data into the existing networks. So the use of a comb allows you to eliminate guard bands between the channels and basically maximize the capacity of your system. So the achievements to date are basically to design and architect this PIC, to lay it out to kind of model it, simulate it, and really put it through its paces, and then to lay it out for submission to the fab. In parallel to that, then we're working on the packaging and assembly of that, how we can basically get electricity into this PIC and light out of it in a form factor that can then be evaluated by our customers. And so then the manufacturing of the PIC is now in progress, and the PICs are expected out in May of this year. So we're very excited about that and the benefits that can bring. So that's just a quick overview of the project. So in summary, we're developing cone-based super channel transceivers to basically increase the capacity of the long haul networks that make up the internet. ActFast has given us access to key partnerships, expertise, and technology throughout Europe to accelerate our route to market. In our case, we had existing in-house PIC design expertise, but I know that ActFast also caters for non-specialist companies, and in fact they provide a lot of the support to bring your photonics innovation into let's say non-photonics companies. In our case, it's been already highly successful from what we've been able to achieve so far. We have a number of large tier one customers in the optical communication space looking to evaluate our PICs when the fabrication is complete. So we're lining up a series of technology evaluations with our customers. So in summary, I guess I would highly recommend ActFast for any innovative companies that want to bring their photonics innovation to life and to add photonics value to their existing products. Thank you very much.
Thank you very much, Frank, for the inspiration. And by the way, how do you find this? How did you find this ActFast platform? You know, how the information reached your company, you know?
Yeah, so we had, in our case, we had, as I said, carried out an ActFast project maybe 4 or 5 years ago through one of the earlier initiations of ActFast. And actually we found it through, by chance, a colleague of ours had previously worked with one of the ActFast team, Peter Doyle, who's one of the coordinators of ActFast, and he introduced us, told us the huge benefits that there's access to really the leading edge photonics institutions around Europe, and introduced us to the scheme. And then we went through the process that I outlined, and it's very straightforward. I mean, within certainly less than 3 months, even faster, sometimes you can go from idea to project kickoff. I would, as I said, I would highly recommend it. It's been hugely valuable to our company. We're still seeing commercial benefits from our first ActFast project, and now we're very much looking forward to the outcomes of the second, even more ambitious project.
Okay, thank you Frank, for encouraging all of us, and project implementers and the other SMEs who are willing, to submit proposals. Yes, and I do not see any more questions for you. So thank you for joining us, and
no problem.
bye-bye.
Thank you.
Okay, thank
Bye-bye.
you. Yeah, ladies.
Thank you, Julius, for so good managing time. We are exactly on that schedule. And now I ask all participants on the Zoom area to switch on cameras. We'll try to make some roundtable discussion to encourage more companies to join us. Yeah. And my first question goes to those who are presenting best practice. You can ask some RTOs or universities for some help in your development. But what additional you are getting for this kind of a project when you apply for this open call?
Yeah, I could address that. I mean, there are numerous kind of additional benefits that we have felt from our participation in ActFast. ActFast is also heavily involved in an annual event called the European Photonics Venture Forum. And it was through ActFast that we actually heard about that event, and actually we've participated 3 times, and we've been selected as winners in that forum on 2 of those occasions, and that has led to us receiving term sheets from a potential investor into the company, which we're working through at the moment. So that's a huge kind of fringe benefit to our involvement with ActFast. Another item I would mention is that we were able to cite our involvement with ActFast in our SME instrument phase 2 proposal, and it builds credibility that you can actually achieve what you're saying you're going to do in these large SME innovation proposals. So there's a number of fringe benefits beyond just the kind of technology that you and the prototypes that you'll get out at the other end of the project.
In our case, I would like to emphasize that this kind of open calls have led us to make a quick proof of concept using the knowledge, having the support of the centers that we are collaborating with, and this allows to, as I said, to improve the time to market, to bring at least to improve the TRL of your solution, and also reduce the time to market to bring that into a final product that you will offer commercially. I think this is one big advantage for us as an SME, because it lets you, this kind of open calls let you test something really quickly, being funded, and improve the TRL of your solution. And that I think is really important when you are a small company to have that support.
Marta, from your side?
Yeah, that's in fact very interesting what you were saying, and yeah, I would like to maybe to repeat, but for us it was very important not only to focus on the technical side, because we all engineers tend to go to the technical side very deep inside and so, but we forget sometimes about business assessment and to analyze the critical point, the risk, and so, and that helped us a lot as well. Just to follow up the activity and not to forget any important points that maybe is a high risk that, maybe you can identify the action to be taken, but if not, maybe it's as well important to know if it is a good experiment or not. Even if it fails, it's good for you, because then you will not, drain more money into it, and you just forget about it and go to the next question. Then, yeah, I think it's really useful.
Sorry, I really agree with Marta, because we're seeing in a recent open innovation call that we are participating, it's not only the technical support, but also the business development, the way to build a solid business plan to commercialize or to bring the solution or the result of the development into the market, having like a foundation, having some basis of identified who the customers may be or how to deal with them. Sorry, I didn't mention that, but it's also a great support that you get from the business perspective as well.
Okay. Thanks. Now my question to the speakers. Really, we see, at least in our country, that companies are having some problems. They don't like to open that to everybody, to looking for in the broad scope of this solutions. Maybe the best solution that could be exist in Europe, not simply in your close to your home. How we should remove those fears hindering disclosure of this idea? Egidius.
Actually, the main problem is our part of financial percentage, mainly. Another problem is really some kind of statement of difficulties for the company. Actually, we use a lot of our money for development, and we got bad statement for the money. It means that we have on the minus situation, and in this case, no one program can make any financing for us. We really, all the programs is closed for us. So in this case, really, how to say, just question of, I think that should be question of the quality of the proposals, not on the situation of the company. And if really there is some reason to get good result, in this case, should be possible to make some compromise for financing. So that is main fears for in our case, for example.
Okay, Julius, what's from your side?
I would like to agree with Egidius about the possibilities to take, let's say, to use the open calls, and if you have minus balance, no one is looking for you. Other opportunity is not to scare to try this open call and to speak with people who are responsible in those, let's say, in PhotonHUB and other companies. And if we are looking in Lithuania, I think that we need more education about how we can go and how we can reach those open calls, let's say not in Lithuania environment, but abroad in Europe. So I think education is a must for Lithuanian companies, and we have to educate and educate and educate more and more, that all this information reach the specific companies, that they would not scared to apply to such advantages.
Evaldas, what's your opinion in this phase?
Well, the biggest challenges for us is finding partners in Europe, because having partners here in Lithuania is okay. I mean, we know everybody and everybody knows us, so it's not a problem. But once we want to go to bigger projects, or at least have an introduction with such open calls as a preparation for a bigger project, let's say, then, well, the biggest challenge is to find right partners and gain their trust. So there we must communicate our country, our history in laser physics as the key, and then hope that, you know, people in Germany, in Spain, and in France will find us trustful partners and capable partners of doing photonics.
But for open calls now, Funding Box is quite involved in many projects, and they have some special matchmaking areas for nearly every of those projects. So there is a lot of room to find the partners. I now also discussing, because we're now discussing about 2 projects on lasers and photonics, but there are also on robotics, artificial intelligence, twins, etc. And how to make that single spot in Lithuania, that's people that have some idea, they came and somebody has, okay, you should go to artificial intelligence, not to photonics. It's one question what we should do, and really it's more like a combination of those many digital innovation hubs we have in Lithuania, 18 digital innovation hubs. It's really we need to combine everything in one piece to make more prominent. Kęstutis, your insight from that side. Switch your microphone on.
Sorry, forget about microphone. So actually, our situation is really different from other presenters. For smaller companies, we are a bigger company, and usually we are invited in some calls or some projects or some ideas according to our technology. We are not looking for. So we are choosing from projects to projects, and it's just aligning it to our needs, to our tasks and strategy. So, but it was not all time. Of course, maybe 10 or 15 years ago, it was more complicated, and when we started to participate in international calls. But in that case, we started from our initiative to be open, to be, let's say, to show everyone what technology we have, what technology we can share. And the first thing it was not easy to step out, but we did. Not afraid to be open, not afraid to disclose what we have, because by sharing, usually to get more than lost. So our start was from that policy, and now we have situation what we can choose from inventions. So.
Thank you. Now my question to Hugo. How such projects, how we can encourage companies to apply as much as possible? As more companies apply, more proposals are receiving those projects, we selecting the better, and so we also may make more active those small companies in the pool.
I think the best way to motivate SMEs to participate is by giving a lot of excellent examples of SMEs that went through the motion, that worked with us, and that created a fantastic increase in their revenues, created new jobs, that created new products. And all of that is possible. I mean, when I hear Frank's testimonial from Pilot Photonics, I mean, that's the best we can do, okay? If the company themselves give the example and say that they have really benefited from support from ActFast, which is the predecessor of PhotonHUB, then that is the best we can have. When we had a workshop a year ago in Florence, in Italy, all of a sudden I was giving a presentation about what we could do for the SMEs, and at a certain moment, one company stood up and said, "We have benefited from ActFast. People in the room, please listen to me. You should really go there. They will really be able to support you." I think that is the best you can have at that moment. The companies themselves that are inviting other companies to take benefit from services from ActFast and PhotonHUB. That's the best you can have. The mouth-to-mouth advertisement.
Thank you. It's Francesca initiated this meeting. It's really, we try to collect all this. The companies, they have ideas, the companies, they have experience, and some projects that they have to try. Francesca, your ideas.
Yeah, so I have to comment on what just Hugo said, because I have to say from my previous job where I was involved in let's say a consortium of funding agencies in astroparticle physics, actually one of the things that connects me from now to there is act fast. So because I already heard about it there by then, and so now it's still like we are talking about the inheritance of that. So I have to say definitely act fast had a really nice spreading. So that's important that this is still valid, and now with new activities we have to really get the same power of that everybody has to know what PULSATE and PhotonHUB can do, because that is really what will help us in really involving also the manufacturing side, all the end users of photonics that is actually are those that are there. And so that's the good thing that really is important to have a good advertisement. And I mean, we are there also for this, so dissemination outreach, especially with also Natalie from the side of PhotonHUB, and also Funding Box, of course, that is both partner for us and EPIC. And then I have to comment also to what Evalda said. Let me say, if you want to get international, of course, EPIC is also the good address. Let me make a bit of advertisement of EPIC as well, as an association of so many companies in photonics. So that's also a good way. But here we are talking about these initiatives, and these are those that we want to have really long lasting. So it's good to start with good advertisement and good work together, like this event, and then bring it on and hand by hand get more and more companies on board that can profit, of course, from the commission efforts to help photonics.
But such also initiative finally goes to some local clusters, regional clusters and organization. Julius, what's your insights?
Yes, thank you, Gediminas. The cluster's role is also very important, to communicate every day, with the company, to know their some problems, to know their plans about innovations, and to see all the perspective of this PULSATE and PhotonHUB Europe. Yes, it's crucial, because maybe not everybody will see the the advertisement somewhere on the LinkedIn or somewhere, and not every company will be encouraged. And in Lithuania, it's really talking about the region of Lithuania. It's really pretty compact, country, and more or less we know all the industries. And from photonics and non-photonics companies, yes, and this helps a lot, to bring this PhotonHUB Europe and PULSATE idea closer to the companies. Yeah. Thank you.
Christina, now it's your turn.
So I'll be very short because a lot of good ideas was already mentioned. So from my perspective, as I'm a representative of a cluster, I think one of the advantages is that cluster manager, as me, is one help that can bring one company closer to other company. Because first of all, I know a lot of companies. For example, from my spectrum is from photonics and laser field. So I know people, and if someone maybe from robotics or from someone else comes and says that, Christina, I need someone from that and that company, or I need some technology, can you help me find something? Then I'm, as a person that this company knows, I can reach better, and I can say that these guys are really great and that they can really do. And sometimes 5 minutes of talking with people that you know, person that you know, is much better than 10 YouTube advertisements and etc. So it's all about the networking and being out there and saying that you can help them. And it works in both ways, not only bringing companies to photonics, but also photonics bringing to other companies.
Thank you, Christina. It was, for us, it's quite good exercise to adjust our triangle to work in a integrated way for everything. Does have some of your ideas to share with us before we are going to networking room for informal discussion. So that's coming back to PULSATE and PhotonHUB. So matchmaking session for the all PULSATE will be this Friday. Please look on the funding box. And if there are some questions, we are planning still some similar event in local language, in Lithuanian language for local companies. If there are some requests, as you know, the deadline for PULSATE is April 22, so we still have a little time for that. It's really good that we can find some right consortium in this way, and really those even looking quite close to projects, and we see some similarities and differences. We can select what is the best way. Okay, so thank you everybody, all the speakers, all attendees, and now I invite everybody to network room for virtual coffee and informal discussion. Okay, thank you.
Thank you.
Thank you, bye-bye.